All right. Hello, everyone. Can you hear me okay? Yes, well, so nice to see everyone today, whether it's morning or afternoon or night, wherever you are in the world. Indeed, if you haven't already, please feel free to say hi and where you're from in the chat window here today. Welcome to everyone, including welcome to an amazing team of mentors that have wonderfully been volunteering over the past few weeks to answer questions in the Zoom chat, as well as via Ed, the course's Q&A platform. Indeed, in today's seminar, if you have any technical questions or curricular questions or the like, please do feel free to ask questions of each other in the chat, as well as on that same platform, Ed. And if at any point you find yourself falling behind, have technical difficulties, can't quite get the software itself working, not to worry. Feel free to continue to listen and follow along today, and then work through things at your own pace online, since we'll post the video and the slides and the code and everything on the course's website after this as well. Before we begin, as many of you know, we have this tradition of taking a group photo. If you'd like to do this, go ahead and turn on your camera if it's not on already. If you don't want to be on camera right now, go ahead and turn your camera off. And in just a moment, we'll need everyone to go ahead and put on your best smile if you're feeling happy right now, and a bit of a wave. And our colleague Tara behind the scenes is going to go ahead and take a whole bunch of screenshots that we're going to then use some fancy software to stitch together one big mosaic that we'll post on the course's website afterward, so that you have a little souvenir photo from learning about today's topic. We need just a few more seconds of this.
All set, David.
And we're good.
Yeah.
Thank you all. So pleased today to be joined by CS50's own Valerie behind the scenes, who will be here in the chat to help answer and proxy questions, as well as our special instructor for today, CS50's own Colton Ogden. The topic, of course, is game development. And what I like to think is particularly special about developing games is that it's a domain that all of us are likely familiar with, whether it's nostalgia, thinking back on childhood, playing video games of some sort, or nowadays maybe on your PC, your console, or your phone. And what's wonderful about learning about game development, I think, is it sort of unlocks this capability to make the very kinds of things that you yourself like playing, or you yourself liked playing growing up. And indeed, among the goals today is to give you just a taste of that development. And if you find yourself really liking this world, Colton actually teaches a whole course that's freely available online that we'll provide a URL to in the chat, via which you can dive in more deeply, not only to today's game, but so many games as well. So with all that said, allow me to introduce today's teacher, CS50's own Colton.
Awesome. Thanks so much, David. Indeed, this is a pre-CS50 Games edition. I'm just going to go ahead and share my screen here real quick, because I have a slide deck to supplement everything here. So all of you should now be able to see my slides. I'm also going to make sure that I can see the chat as well. So I'll be looking at the chat. So definitely, as David said, do feel free to post in the chat. We have a lovely team of mentors here looking. In case I do miss your question, I apologize if you ask a question or a comment. But this is pre-CS50 Games Edition. And as David said, you know, games are a fun thing many of us have gotten certainly acquainted with throughout our lives. I being a sort of a key example of that, I play a lot of games. But as you can see on the slide deck here, there's a picture of a Pong console. So today we'll be looking at a really classic game, which is nice and simple, but also illustrative of a lot of the core pieces of game development, or at least is a good way to illustrate all of those core principles. That being Pong, which was released in the 70s or so. And here's what it'll look like by the time we're done today, at least the title screen thereof. It says here pre-50 Pong. It's got scores in the middle. You can see there's not really a whole lot going on graphically. We do have sort of the paddles on the left and the right, the ball in the center. We have text being drawn on the screen. So we don't have to worry too much about a lot of details related to graphics, but we do have to talk about things like moving paddles. We have to talk about primitive physics with the ball bouncing off the walls and the paddles. And then there is some graphics in as much as text, shapes, and the like. In order to get us started, though, we're going to have to actually get set up with means of creating games and sort of rendering them, deploying them. And we'll be using two key things to do that today, those being a programming language called Lua, shown by the image on the left side of the screen there. And then on the right side, we have an image for the framework, which is the term we'll be using, called Love 2D specifically. So in order to get started, Valerie and others will be posting links in the chat with instructions on how to get set up for your operating system if you're on a Windows machine or a Mac in particular, although there are Linux instructions on the Love2D website as well. If you go to love2d.org in particular, I'm just going to make sure I demonstrate what that should look like here. So if you're on love2d.org, if it just refreshes here really quick, I think it might just be refreshing the same page there. So this is what the homepage looks like, love2d.org. It's got installers for Windows and Mac and Linux and other operating systems. You can even get it set up to run applications on Android and iOS if that is of interest. And if you go to the Getting Started page, love2d.org/wiki/getting started, you can see much more thorough instructions for how to get set up for your operating system in case you want to get set up in other ways besides the instructions that we have gotten set up. Now, we officially recommend, for the sake of this seminar at least, and even in general for developing with Love2D, that you get set up with a text editor called Visual Studio Code, or VS Code, which I use a lot and which other members of CS50 also use. In particular, because there is a really handy plugin that you can install on your machine that will let you run Love2D apps, Love2D programs with just a hotkey press or a key combination press, so it's super convenient. Otherwise, you'll have to typically be dragging a folder with a LUL file in it onto, the executable or shortcut on your computer. Or if you're using a CLI, if you're on Linux, you'll have to type in a command at the command prompt to do so. So this kind of saves a little bit of mental bandwidth at the very least, and if not time and efficiency. So, and we'll have links being posted to describe that setup in a little bit more detail for at least Mac and Windows. And if you're on Linux machine, it'll be a similar process, and you can see instructions for how to use Love at the command line on that Getting Started page. So I'm just going to be looking at the periodically at the chat to see if I'm not missing any questions. Do feel free to post in the chat, and I'll do my best to read up. And if I miss any questions, Valerie will assist, and mentors will be assisting as well, especially as we get into the process of writing code. Certainly do feel free to post questions. If there are any questions related to your setup, for example, as we get started, as you're getting set up, if things, if there's a technical hurdle that you run into, do feel free to post questions in the chat or on the Ed discussion group, which is a site that the course has been using for various purposes throughout the seminar's running period, and then folks will assist there. We won't have a ton of time to troubleshoot specific technical problems as they come up, but as David said in the beginning, don't feel discouraged if you run into those problems and you have trouble keeping up. The video, the lecture, or the source code for everything will be posted online. On GitHub in particular, we have been posting the source code for every iteration of the seminar, including this one, so you can follow along at your own pace in the future, worst case. Devin asks, do we also need the source code? No, we will be writing everything from scratch, but I will be posting the source code to GitHub following the seminar's conclusion. So you can use that to catch up later if you wish. And actually, I will post a link to the source code from the previous seminars, which you can see on my screen there. This way, at least if you want to get ahead, you want to take a sneak peek at what to expect, you can certainly do so. Although if you want things to be blind, or if you want to sort of follow along without knowledge of what's to come, you can avoid spoiling. But if you want to use it as a crutch, or if you want to use it to look ahead, certainly do feel free to do so. And then Valerie's just posted slides as well, so you can follow along with my slide deck. Nashia says, using the Command L shortcut from the instructions, says that the executable path does not exist. Yeah, it could be the case that you don't have the executable in the correct location. So do just make sure that that field correlates with where it actually is installed on your machine. So for example, if I go to my extensions, so just as to cover the actual extension, how to get it set up in VS Code. Once you get VS Code set up, the text editor, and you want to use that tool that I alluded to that lets you run the programs really quick, you want to go up here and in the extensions menu on the left side of VS Code, or using Control Shift or Command Shift X for extension, you can pull this up and just type in Love2D support. You'll see this Pixelbyte Studios plugin. You want to install that. Once it's installed, there's a cogwheel that you can use to manage and go to your settings. Once you have that set up, there's a file path here. Depending on what operating system you're running, this will differ. On Windows, if you run the default installer from the Love2D website, you'll see that it should by default point you to your default hard drive, program files, love.exe. If you're on Mac, you want that to be in your applications, love.app/contents macOS resources love. All those instructions are in the instructions that were posted in the chat, so do follow along with those. And if you're on Linux, this will be in a different location, but you can still point to this and it should still work if you're using a graphical version of Linux. But just make sure that this path echoes where your executable is for your operating system. And again, if you have trouble running this or getting this to work, if your setup slightly differs from what we expect in the course, do feel free to post an ed or the chat, and hopefully somebody can assist with troubleshooting that. But yeah, once you all set up with that, you should be able to hit Command L or Alt L if you're on a Command L or Alt L on a Windows, Command L on a Mac to run the application. David appreciates my username. I appreciate that. Thank you. How to set up Visual Studio Code for the class. So that should just be a relatively straightforward installation. So you want to go to Visual Studio Code in Google, which would be code.visualstudiocode.com. You can download the version for your operating system. They make it nice and straightforward. So just do that first. That'll be obviously the first step. And then once that's installed, then you can go into the extension menu. And I'll post this link in the chat as well in case folks wish to click on that. All right. For Love, are we supposed to download Linux? No, you just, whatever computer you're currently on, you should be able to run it on that operating system. Linux is an option, but certainly not requisite. All right. RNAS macOS Path for Love in the extension. It'll be in the instructions that we posted. So if you check on that, there's a particular way that for Mac that you need to write the path, because it actually looks for an executable within the love.app bundle, because in macOS Love or any .app is really a sort of a folder structure with a bunch of different subfolders. So there's going to be a particular way that you have to write it in there. But once you have that written correctly, you should be able to run it just like you would run it in Windows, pointing to the exe. Charles, yes, that will be the path, but do make sure that it actually is installed there. Because if you download, for example, the installer zip, it will not actually install it on your machine. It'll just be in a folder somewhere. So on Windows, in order for it to be at that path, it has to be installed via the Windows installer version from Love2D, not the zip version. Yeah, and as long as folks have a way to run the code. So worst case, if folks are having trouble running the shortcut via the Pixelbyte Studios plugin, you should be able to just click and drag your folder, wherever your folder is for your code, which we'll talk about in just a moment. You can drag that onto your Love2D executable, whether you're on a Windows or Mac or even a Linux machine. This should work. Make sure the folder is dragged onto the application. This will also run your code equivalently. Or if you're on Linux and you followed the other installation instructions on Love2D's website, it's a command line string that you'll probably execute, in which case you can just use that rather than having to use this shortcut. But either way, whether you're running it through a graphical means or through the extension, as long as you have a way to run the code, you'll be able to follow along just fine. And again, if you're having issues, do post them in the chat and mentors will be able to assist you. Okay. And then folks are asking, when running a program, the Love executable path, how do you check where the executable is? So that'll be where, if you're on a Mac and you download the Love zip and you unzip it, there will be an app in there, a love.app. You want to make sure you put that in your applications folder. So this is in the instructions. Make sure the love.app is in your applications folder, at which point you should be able to copy the string /application/love.app/ so on and so forth, as illustrated in the instructions. It's a particular way to get it to work on Mac. And then put that in your field in the extension settings, and then that should work on Mac OS. It's a little bit more work on Mac OS to get it working properly than it is on Windows, unfortunately. All right, so I'm going to go ahead and forge ahead now. So hopefully most folks are able to, if not getting it run through Pixelbyte, at least getting it run through, clicking and dragging code, which you'll be able to test in just a second. I'm going to pop back to my slides here, because before we actually get started writing code, I kind of wanted to talk about how I think of games at a sort of abstract conceptual level. And then as we go along, we'll get a little bit deeper and deeper, and we'll talk about things in a more technical sense. But at least to begin with, a game, in my opinion, if folks are familiar, this is a picture of a flip book, which is sort of a set of pieces of paper or sticky notes or flashcards that you would put in a rather thick bundle, each with a picture drawn on them. But there's going to be slight differences between each picture. So one picture will be slightly different than the next, and so on and so forth. And in composite, when flipped through, relatively quickly, this will give you the illusion of an animation taking place. You know, something might be moving or a person might be doing an action. Whatever you decide to animate on your sticky notes or your flashcards, this flipbook illustrates animation. This is how 2D animation, you know, generally speaking, works. You know, things like cartoons and the like. But with games, games are this, but almost as if you yourself were drawing the flipbook as you were, you know, sort of progressing through it, as you were flipping through it. You are, you know, trying to present this animation, but you're also doing an update on what's being drawn every single piece of the picture, every single illustration, every single frame of animation. And this is in the abstract sense, what a game is, or what a game is seeking to do or seeking to be, you know, related to what somebody's doing, what somebody's pressing, what somebody's input is to the game, you know, whatever they're using, mouse, keyboard, controller, microphone, you name it. This has an effect on some state, some sort of set of variables, numbers, or strings, or the like. And then following those things changing, you then update, and then you rinse and repeat the cycle over and over again. And this is illustrated more technically with this diagram here, which shows this thing called a game loop, which is basically an infinite set of steps, series of steps sequentially, but that just does exactly what I said a second ago. We process input, meaning we take in whatever the user decides to press at the keyboard or mouse or the controller. We update our game state, whatever set of variables, set of numbers and strings and whatnot we decided represents whatever exists in our game. Sometimes we update this multiple times per frame, depending on how fast or slow our machine is. And then we render everything, that is, draw everything to the screen based upon what just got updated in our game engine. And then as shown by the arrow at the bottom, everything kind of goes back full circle and we start over again. We process input, we update maybe multiple times, and then we render. And this flow takes place every sort of frame of animation or frame of our game engine updating, which is typically 1/60th of a second or 1/30th of a second if you're on a console often, because this typically tends to be the refresh rate of most monitors these days. So to echo this game loop, in an even more technical sense, I figured this is a perfect time for us to actually jump into some of the code and to see what this will look like in source code. So again, I'm just going to try to look at the chat and make sure that things are not getting missed. So folks are suggesting to follow along on YouTube in case you do get behind. Yeah, absolutely. If you do get behind and you want to catch up, you have that option. You can look on YouTube. Alternatively, you can certainly keep along conceptually and then follow along at a later time if you wish. But this will of course differ depending on what you're seeking from the seminar. So I'm in Visual Studio Code right here. Now you're going to want to create a folder somewhere on your computer. I've got a folder already set up with all the source code from prior seminars, the GitHub repo particularly. And you can see there's a live and a live 2 and a pre folder in here. I'm going to create a new folder within this folder. Now, this isn't something you need to do, but this is, you can pretend this is your folder. I'm going to call this live 3 because this is the third iteration of this seminar. So on your computer somewhere, you're going to want a folder. And then within that folder, you're going to want to create a new file in VS Code. That's, you can use Control-N to create a new file. And I'm going to call this main.lua. And if folks have coded in C or C++ or Python even, you might have seen this name, this word, this term main, which typically means the execution point, the starting point of your program. It's where you're, you know, whether you're in C or whether you're in something else, Java, that's going to be looking, Java or C is going to be looking for this keyword main. It's going to be looking for that to sort of start up or bootstrap your application. In the case of Love2D, if you've downloaded Love2D and gotten that started and you're able to run the source code, in particular main.lua, the folder that contains main.lua, it's going to look for this file main.lua. You know, it expects a directory. It expects to be pointed to a folder somewhere. And then it's going to look inside that folder and it's going to say, hey, where's main.lua? And then it's going to open that up and it's going to look for a set of particular functions therein. Function being a sort of bundle of code that you write, sort of literally with the word function. And it's going to look for a set of functions with a particular name. So if I say, for example, function love.draw, and I put parentheses there, and I use the keyword end to say that I'm going to end the function, this is going to be one of the specific functions that Love2D knows should exist in main.lua. It's going to look for that, and then it's going to execute that basically for us in its own implementation of a game loop. So for example, I can say, function love.draw, and within that I can say love.graphics.print, and I can say hello world, passing it in a string using these single quotes. You can also use double quotes. And if I do that, and assuming everything is set up correctly on my machine, I can then hit Alt L. And indeed, I do have this window that popped up, this black window that has this text, which is really small to see. But assuming everything worked correctly, you should be able to see hello world in white text there at the very top left. And this is just a sanity check to make sure that we have everything set up. Alternatively, if you don't have Pixelbyte plugin installed correctly, you can click and drag your folder onto Love2D, wherever it is on your computer, and run it that way. But either way, you should see, assuming that you've typed this code without any typos, that text, that white text shown on the screen. So let me just make sure I am looking at the chat here. So folks are kindly suggesting troubleshooting instructions. Some folks have said that they've got it working, which is great to hear. I'm very happy about that. How do I quick scope? We won't quite get to that level of sophistication in this seminar, but if curious, do maybe download Unity and explore some first-person tutorials. Pong predated quickscoping by about 30 years. So, all right, very good. A lot of people are posting positive comments about how they've had success getting things to work. So I'm very happy to hear that. So this is just one function that Love expects. And if we go back to our loop, you can see here there are a set of steps. What we have just done is actually injected our own version of what render should be. Our own love.draw function is effectively that render box. Love2D is beautiful in that it essentially takes care of the render loop for us. If you've taken CS50 or other courses that sort of deal with introductory programming, you might have been introduced to the idea of an infinite loop and sort of gone under the impression that infinite loops are a bad thing. And typically they tend to be bad things. They tend to be bugs that crash your computer. Oftentimes, whether it's the spinning beach ball or whether it's your own CLI program that just tends to not be responding and you have to hard execute it with Control-C or the like, infinite loops tend to be bugs. But there are applications and examples of things where infinite loops are good things. For example, if you're in the web browser and you're looking at a web page, refreshing the contents of the web page is a good infinite loop. A server listening online for clients to be sending it requests and for it therefore to send responses, that is an example of an infinite loop. That's a good thing. We want servers online 24/7 to handle network traffic. With games are infinite loops where we're doing this process input, update, render over and over and over again every single frame until we quit the program basically. And this process we do want to continue forever, or our game is just going to freeze and crash, which will be a negative thing. So games or infinite loops, generally speaking, are bad things, but there are examples where they can be good things. And Love2D, fortunately, actually takes care of the mechanical details of setting up the infinite loop for us. It knows when we define this love.draw function, basically where to inject it into an infinite loop that it manages sort of behind the scenes. So all we really have to do is worry about these specific boxes, these specific puzzle pieces here, processing input, updating the game, rendering. We take care of implementing that, and then Love can actually take care of managing all of where those should occur and in what order and with which frequency. So for example, love.draw is a function that's important, but we could also say function love.update, which takes in a parameter called dt. We'll talk about that later. That's, for example, the update piece of the chunk here, right? Love knows where to inject that if we define it. And then if we also wanted to say function love.keyPressed, taking in a key parameter, well, that's the same thing as this process input box. And processing input also takes place within the update function, which we'll see a little bit later. But these three pieces are effectively the analogs to the game loop pieces that we just saw in that diagram. And thankfully, Love2D is so simple in that all we have to do is define the pieces. We don't have to manage the technical overload of making sure that they loop and occur correctly. All right, let me just make sure I'm taking a look here at chat. So folks are having some syntax issues, but hopefully folks are able to take a look. Hardev asks, is that why games are so resource intensive? Well, yeah, because you're effectively doing 1/6 of a second. Within 17 milliseconds, you're having to take care of the act of checking input, updating based on that input, all of the game variables in your state, and then drawing everything to the screen. And given a sophisticated enough environment, that can certainly be a tremendous amount to do, especially as you get into the realm of 3D games. Absolutely. All right, just skimming chat here really quick. I'll be doing this periodically to make sure I don't miss anything, hopefully. Shivam is saying only the black screen appears. What to do? If a black screen appears, it's at least working, but things are not being drawn to the screen correctly. So I would just make sure that love.graphics.print is being written out correctly. You have the text being written here correctly. By default, it should just work, assuming that is the case. And yeah, folks are saying maybe you didn't save. True, that I did that last seminar iteration. I forgot to save, and I was wondering why things were not working correctly. And again, if folks are having trouble running it through the extension, through the Alt-L or Command-L process, you can click and drag your folder onto Love2D. If you have a shortcut on Windows on your desktop or whatnot, or you pinned it to your taskbar, or if on Windows you've dragged the reference to it to your dock, that's equivalently the same thing. Just drag the folder onto the program, that will run it. As long as you're dragging a folder that contains the main.lua, that will work just the same as using the Pixelbyte extension, just a little bit more manual, admittedly. Correct, folder, not the file. Don't drag the main.lua file, drag the folder that contains the main.lua file onto the program, or a reference to the program. All right, so folks are already getting ahead of things and talking about delta time. We'll get there. I do promise we'll get to delta time. It's a very tremendously important thing, but not quite yet. All right. So going from sort of talking about the basic building blocks, how to define them using functions in Lua. So this is Lua syntax, not to be confused with Love2D. Love is a framework that uses Lua as the language, but this language that we're using right now, folks might not have seen this language. This is called Lua, and it's a very straightforward, simple, small language, kind of like C is in terms of, at least in reference to other sort of compiled languages. It's a very small language. If folks have used JavaScript or Python, you'll probably kind of feel like it has a Python/JavaScript-esque flavor to it, which it certainly does. With admittedly its own set of quirks. For example, this end keyword is very unique to Lua, kind of reminiscent of Bash scripting, if folks are familiar. But not to dive too much into those details, I figured it might be nice to talk next about something very important at a sort of conceptual and technical level before we get into drawing stuff and getting into more interesting things like drawing paddles and moving them around. We have to talk about the 2D coordinate system. So 2D games are essentially a series of objects that we draw and move around in just this 2D sort of Cartesian plane. If folks have taken geometry or algebra, this probably looks somewhat familiar. Essentially, our screen is this window here that we're looking at, this diagram, where we have at the top left corner this origin point, so to speak, which is an XY coordinate pair, which starts at 0, 0 for XY. Everything that we draw on the screen is going to need to have an XY pair in order to be drawn appropriately by the Love2D engine. And if we move that X positive on the X axis, going left to right, it's going to move to the right. And conversely, negative directions will move to the left, or lesser values will move to the left. And then the same thing is true for Y, but in the opposite axis. So Y positive values will go down, negative values will go up, which makes intuitive sense if we consider that the origin is located at the top left. And then, of course, the screen width, 0 is going to be the far right corner of the screen at the top, and then 0 height will be the very bottom of the screen at x0, but at the height level on the Y, and then of course the very bottom right will be width, height. So the farthest on the X, farthest on the Y. Now, everything takes these XY coordinate pairs, including text, and by default, because we didn't pass in, for example, in our code, an XY pair in this hello world, our text got drawn at the very top left of the screen, so at 0, 0. But if we were to say put in 100, 100 as our XY pair as further arguments to love.graphics.print, and then we rerun the program, you'll see that our text gets drawn offset by 100 pixels, both in the X and the Y direction. So these XY values are being used no matter what you draw to the screen, but sometimes maybe not explicitly so. Before we get into drawing more things though, I'm not a huge fan of how small this text is on the screen. Now, Pong, when it was released back in the 70s, it, obviously very limited resolution on things. If you weren't dealing with a vector-based implementation of Pong, certainly a lot of games for like the Atari and the Nintendo and the Super Nintendo were dealing with resolutions that were, 200 pixels wide or 100 pixels tall or 300 pixels wide. And that's more along the lines that I like to think as I'm creating games and projects that try to mimic that feeling of old school titles, of more retro titles. And to that end, what I want to do is I want to feel like I'm drawing to something like a 380 by 200 pixel resolution, but still be able to draw on my operating system, to have it output to windows that are 1280 by 720 or 1920 by 1080 large. And the two being sort of separated kind of is a technical hurdle that I don't even want to think about. So what I want to do is I want to use a library to manage this. And there is a great library that I'm going to link to on GitHub called Push that is specifically made for Love 2D, which lets us think in terms of a virtual resolution. So I can say, I want my window to be 384 by 216 or some small resolution that fits a 16 by 9 aspect ratio. In other words, is the same ratio as something like 1080p, but much lower res, so that we feel like we're drawing for an older system. So I'm going to copy a reference to this library in the Zoom chat here, so you can follow along with me. If you download the zip for this, if you go to the download zip on GitHub, we're going to want just this push.lua file. So if you unzip it, you'll see a main.lua and a push.lua file in there. Just grab that push.lua file and put that in the same folder as your seminar code. In this case, I already have it in other versions of the seminar, so I'm just going to copy it from those folders and paste it in. But you're going to want to grab it from that GitHub repository. And as you can see here, if you're looking, it's a lot. There's a lot of crazy code happening in there. And we're not going to worry about any of this at all. We're not going to dive into the technical details. We're just going to be aware that its purpose in life is to give us this virtual resolution so that we can do a few following things to get us set up. And I'm going to look at the chat before we forge ahead, just to make sure I'm not getting too far ahead. Folks are saying which file. It's going to be the push.lua file located in that repository. I posted the link in the chat. So if you download that repo and get the zip from it, or clone it if you're using Git, grab the push.lua, put that in the same folder as your main.lua that you just created for the seminar. And then this is what's called a library. So we can use this in our code. We can actually import it in much the same way that you would do so in Python or JavaScript if familiar. And if I'm going back to my code here, I can do a few things. I'm gonna define a few variables, and in particular variables that I know are going to be constant variables. So I'm going to capitalize all of them. So I'm going to say virtual width is equal to 384. So this is going to be my virtual resolution, sort of my fake resolution. I'm not going to actually have a 384 by 216 window on my computer because that'd be tiny, especially if you're on something like a 4K monitor. That would be extremely small. But we're going to be drawing to a virtual canvas, so to speak. That's going to be 384 by 216 pixels. So I have two variables, virtual width and not virtual width again, but rather virtual height. And then I'm going to say window width, because this is what my actual window is going to be. Window width is going to be equal to 1280 by 720. You can make this whatever you want, in as far ideally as a 16 by 9 resolution is concerned. You can make it 1920 by 1080. You could make it 4K. I'm using Windows scaling, so I'm going to use a 1280 by 17 or 1280 by 720 resolution, so it doesn't go full screen, so it doesn't get too large, even though I'm on a larger monitor. And then following the definition of those four constant variables, note the fact that we're capitalizing them and using underscores to separate the words. This is just a convention. This doesn't really have any meaning. We could have just as easily said virtual width using camel case. But if we capitalize our variables, it's sort of a signal that, oh, these are constant variables. These shouldn't be changed in the future. Lua is a language that doesn't require us to define what types these variables are. If you're coming from a language like C or Java or C++, this might feel kind of strange, being used to having to say int virtual width, for example, equals 384. But Lua is a dynamic language like Python and JavaScript, so we don't actually have to specify what data type those variables are, right? How do you indicate comments in Lua? So that'll be a double dash like so. You can say double dash, and then you can write whatever you want to follow, and that'll be completely ignored by Lua going forward. 4K Pong, yeah, you could absolutely make 4K Pong. Okay, folks are just posting questions about how to download the code, but it looks like mentors thankfully are assisting. So thanks everybody for helping out. Yeah, alternatively, you can do dash dash hard bracket like so, and then this will create a code block in which you can have multiple lines of code. You absolutely can do that. So following creating those 4 variables, what you want to do is you then say push is equal to require space push. He's passing in the string push. So require is like import or require in Python or JavaScript. It does the same thing. We take the contents of that push file, and then we import it into this push variable, this lowercase push variable. And we don't need to put in .lua. It just knows by default that it should be looking for a .lua file whenever we use the require function. So what this lets us do is now all of the push functionality is going to be located within this push variable. So if I go and I create a new function underneath this called, let's say, love.load, and then I say push colon setup screen. Note the colon here. The colon is very important. So if I say push colon setup screen, what this is going to do, this colon operator, we won't worry about it too much going forward, but it's kind of like this dot operator in love.keyPressed. It basically lets us call a method or a function on something that we can sort of think of as an object if you're coming from Java or other languages that are object oriented. But in Lua, object-oriented programming is kind of more similar to JavaScript in that we kind of have to, it's kind of funky, not really the same kind of object-oriented programming as Java. But for now, just know that whenever we use push, which is only going to be for a few function calls, we need to use this colon operator, not a dot operator. So we say push setup screen, and then we're going to say, I'm going to pass in virtual width and virtual height, as well as window width and window height, the same variables that we had declared previously. What this is going to do is this is going to use push, and it's going to set up our screen such that it'll be ready to draw at 384 by 216, but it's going to draw to our 1280 by 720 window. And this will all make sense here in just a second as to what this all means. In addition to that, we have to do one thing before and after we actually draw to the screen. That's in the love.draw function that we defined previously. Before the print function is executed, you want to, again, use push colon, and then you're going to say start. You're going to execute the start function. So we're going to say, all right, push. We're going to use you to start drawing. We're not going to draw using the default love code. And then we're going to say push finish after love.graphics.print hello world. And you're going to want to make sure you save that. So we've set up our screen in this function called love.load. This is a function, again, like the update, key pressed, and draw function that love expects to exist in our main.lua file. So make sure you run this, and then make sure you do push colon start before love.draw, and then push colon finish with the parentheses to show that we're executing a function before and after we do any drawing. So in this case, just our love.graphics.print. And I'm going to also revert this to be drawing at the top left corner, just for illustration. So assuming all of that works, all of that's been done, and you have your push.lua in the same directory as main.lua, you can run your code. And indeed, if you're looking at my screen, you can see that the hello world is at the very top, but now instead of being super, super tiny, it's much larger. We're actually drawing as if we're doing a 384 by 216 resolution, but this window can be any size, and it will consistently be 384 by, or rather, this window can be, for example, 1280 by 720 or 1920 by 1080, and it will still be drawing a 384 by 216 canvas, because that's the virtual width and the virtual height that we defined up above. So I'm going to take a look at the chat here. Oh, Donna's saying can't get pushed to unzip. Yeah, you're gonna want to use something like by default Mac and Windows should have unzip utilities. You want to double click the zip, make sure you unzip it to your computer somewhere. It's a folder, and then within that folder you'll see a push.lua file. Make sure you grab that push.lua file, drag that into your folder wherever you have your main.lua file. That's gonna obviously differ. The exact program you use is going to differ depending on your operating system, but most operating systems should have an unzip utility at some point. Hani is asking, why is 384 by 216? So we've defined this virtual width and virtual height up here. We pass that into our push setup screen, and push takes care of actually technically getting that working on the screen. We are setting it up for a virtual resolution so that things look retro, they look nice and crisp, they don't look super tiny. When we draw text to the screen, it doesn't look really small. It just doesn't look quite as good when we're doing older games, older retro style games, in my personal opinion. This is flavor. This has nothing really technically imperative within it. You could certainly write this whole program, all the logic within this code at whatever resolution you want. But it certainly feels better when we're talking about older kinds of games, when things look like they're in that same vein. They don't look like they are kind of cruder and done on more modern machines, if that makes sense. This is certainly an aesthetic decision that we are making. Charles asks, so we're showing a 384 by 216 screen in a 1280 by 720 window? Yes, that is exactly what is happening. Or whatever window you decide to put here as your window width and window height, but no matter what, it'll be 384 by 216 because it's going to draw your virtual resolution onto whatever your physical window resolution is. All right. If folks are having technical issues, definitely post them in the chat. Hopefully some folks can assist. I do apologize if folks are running into issues, but again, the mentors are here to assist. And also Ed is a great discussion place to post. People will help out. There's already threads there that might address what you're talking about. And certainly if you get behind, don't feel discouraged. This is probably one of the more technical seminars, and as far as there's a lot of tooling involved, and the topic in and of itself can be kind of a challenge for new folks to programming. But do follow along in the future at your own pace if you wish, or do follow along for now conceptually at the very least. If it takes you a few iterations of watching to understand everything, that is completely beyond normal. This can be a lot, especially if folks are brand new to programming. So do not feel discouraged. Absolutely. All right, so we're going to forge ahead now. So we've got everything running at a virtual resolution, and we have things being drawn to that virtual resolution. So things are going to look better going forward. Now, let's get into a few more interesting topics. The first thing that I want to do probably, though, is if you run the program, you'll notice that it's a little blurry. It doesn't look super great. And that's another piece of the puzzle in getting it to look smooth and crisp on a modern machine. And that's because it's doing what's called filtering. So what it's doing is whenever it draws text to the screen, whenever it draws images to the screen, it performs this operation called texture filtering, where it actually sort of analyzes all the pixels that we're drawing to the screen. And whether we're upscaling or downscaling, it actually looks to see, given an individual pixel and the sort of scaling operation where that pixel maps to in an expanded or shrunk down canvas, it will see, look at the neighboring pixels and determine based on those neighboring pixels what that pixel's color should be. And often this involves filling in the blanks of pixels where otherwise those values wouldn't exist, which gives it this blurry sort of look. These blurry pixels don't exist when it's at a smaller resolution. Now, I don't want that blurry look. I don't want that filtering look because it doesn't really look super great in the context of sort of retro game development. So what I can do in my love.load function is I can say love.graphics.set default filter. This is going to set the default texture filter globally. And I can pass in these two strings, nearest and nearest, two strings for the scale up and scale down operations. So anytime it scales anything up, it's going to use nearest neighbor filtering. And anytime it scales things down, it's going to also use nearest neighbor filtering. Now, this is different from what's called bilinear texture filtering, which is the default, in that instead of trying to fill in the blanks wherever it sees pixels, it's just going to take whatever the literal value would be, whether we scaled up or scaled down that particular pixel, and it's just going to use that color, which has the end result of literally just blowing up our pixels when we scale upwards. So if I save that and then I rerun the code, you can see that if you're looking at the very top here, this may or may not be super clear if you're looking at my screen, depending on the bandwidth, but the pixels are indeed much crisper. This is what it would literally look like if I were taking that old version of the code where it was literally drawing to my screen, and if I had sort of magnified the pixels on my monitor, this is exactly what it would have looked like. And it looks a lot nicer, it looks a lot crisper. This looks a lot more like a retro title, or at least how it should look, right? Sort of the next step beyond that, and that was just a sort of a simple technical detail, no need to necessarily understand the ins and outs of that. The next step is we have sort of the render sort of side of our application, but I'm kind of annoyed at the fact that every time I run the program, I have to go up and I have to click the X at the top right. I kind of don't like that. I would much rather be able to press a key like escape, for example, and be able to quit the application that way. And there's a way to do this very easily. If we go to this love.keyPressed function, which we've had here for a while, you'll notice that it's another love function in that love expects it to exist, but it takes in this key argument. Now, this key argument is actually taken care of for us by love. It actually waits for every time we press a key on our keyboard. It'll actually send a message. In other words, it'll call this function that it defines for us, and it'll say, do we have our own definition of love.keyPressed? If so, pass in that key that we just pressed as an argument. So therefore, we can actually do with that key whatever we want because love is giving it to us. It's basically saying every time I press the key, okay, B is being pressed, N is being pressed, escape's being pressed, enter's being pressed. So that whatever key we just pressed will be this key value. I can do something as simple as if key is equal to literally the string escape, if escape were the key that I wanted to check for, then, and then make sure you have this end as well following that. So you have then and end, and this is how you write if statements in Lua. I can say love.event, which is another sort of almost like a Lego box of sorts. If we think of love.graphics as a box of Legos that has a bunch of graphics functions, love.event is a set of Legos that has event related functions. We can say love.event.quit. And what this has the result of doing is if I run the code and then instead of clicking the X at the top right, if I hit escape, we can see that the game quits just the same. Now we have the ability to check for input. So not only have we tackled the ability to, in our game loop, if we look back at that, not only have we tackled the ability to render our game using love.draw, we've also plugged in our own way of checking for input, processing input via love.keyPressed, which again will be given the key that was ever pressed at the keyboard or the controller or whatever mechanism we've plugged in as an input device to our computer. In this particular case, the keyPressed function is a keyboard specific module, but there are other ways to check for other input as well. Anastasia is asking, what's the point of the push file? It's to allow us to draw a much lower resolution game, for example, 384 by 216, which just happens to be a good sort of NES era, roughly 16 by 9 resolution. But it lets us draw that onto any window size that we want, so that we can draw it on a modern computer at 1280 or 1920 or 3840 if you're on 4K, while still maintaining this virtual resolution of 384 by 216. So no matter what size our window is, it still looks the same. It looks nice and retro and crisp. All right, just making sure I haven't missed too much. Yes, if folks wrote this as one string, these are two separate strings separated by a comma here. So if folks have run into that, two separate parameters, not one string with a comma in the middle of the two strings, but rather a string, comma, another string. Great question, great consideration. All right, just making sure I keep up here with the chat. I apologize if I have missed your question. I will certainly do my best. But again, if folks are having technical issues, I probably won't be able to assist those as much in real time. Rito asked previously why the Hello World appeared blurry. Hopefully we've addressed that since, but that is indeed a result of Love2D's default bilinear filtering we have fixed with this set default filter function call. All right. Why do we write the end keyword? That is a specific Lua thing. So every time we have an if statement, we need a then and an end. Every time we have a function definition, we need an end. This is kind of the analog, if you've used C, of having something like if something and then having the curly brackets like that. Instead, in Lua, this first curly bracket is a then, and then this end curly bracket is an end, and there are no parentheses needed to encapsulate our Boolean expression. We just literally say if something is equal to something or whatever our expression is, with no parentheses needed. that is the analog. You can sort of think it's a Lua specific syntax that is crucial to have. And end is used in a lot of contexts beyond just if as well. The two nearest are bilinear, or they're nearest neighbor filtering as opposed to bilinear filtering, which is the default. Nearest neighbor filtering just means literally upscale the exact pixel values such that when things get upscaled or downscaled, there's just crisp pixelation. There's no smooth interpolation of pixels. So basically that gets rid of the blurriness that we saw before. So good question. The code for escape doesn't work, says Anastasia. So if you do have the if you do have any code related questions, do try and post that in the chat or on Ed if you get behind, which we, unfortunately, if that happens, I do apologize. But do post that in the chat, and hopefully the mentors are going to be around to assist. I know there are certainly a lot of people tuning in, so the chat can certainly get to be quite a lot. But do make sure that folks are saving. Indeed, in the last seminar, I forgot to save. That's a very simple but easy mistake to make. Control S by default in VS Code to save your work. No matter how much experience you might have, it can be something easy to forget to do, especially if you're doing it live in front of hundreds of people. But yeah, do make sure to do that as well if you have new logic that you have not saved. Notice in VS Code, especially if you see this circle up at the top where I have my file, that is a sign that says you have not saved your code yet. So do save if you see that circle shown up above. So with that out of the way, so with some input and with a little bit of work involved, possibly the most maybe magical or less explicit work in the entire seminar with the push library, we can start to dive into something a little bit more interesting, which is maybe getting to drawing the paddle shown in our picture here. So you can see that we have text on the screen, which you've already taken care of how to do with the pre-50 Pong and the press enter. We'll get into how to draw bigger text, how to center, and how to draw scores and the like pretty soon. But the next step, the more interesting step, is how do we get things like shapes onto the screen? Because so far we've drawn text, but obviously Pong is a game about paddles moving around and a ball moving around and bouncing all of that around. In order to do that, it's actually relatively straightforward. So if you come down to love.draw back in our source code, the love.graphics namespace or puzzle box or however you like to think of it, and just as a brief aside, if folks are curious about any of these things, if you go to the love2d.org wiki, which is located at the top of the love2d.org page, and we go over to the left-hand side here, it's gonna be very tiny, probably for you currently, but you'll see all of these love.xyz sort of namespace definitions here in the documentation section, and namespace just being sort of a collection of variables and functions within a particular name. There's a love.graphics link. If you click love.graphics, you can see that it goes into a bunch of awesome detail on how all of the sort of the default stuff works with Love2D. It talks about the coordinate system. It talks about all of the main sort of data types you can work with, all of the functions that are super important. A function in particular that we're going to look at is love.graphics.rectangle, which you can see if you click on any particular function, you'll see what parameters it expects. For example, love.graphics.rectangle expects a mode, an X and a Y, a width and a height, and it knows how to draw that to the screen. If I'm back in Visual Studio Code and I get rid of this love.graphics.print function and I type love.graphics.rectangle, notice that I have the Pixelbyte Studios plugin installed. It knows all of the functions that exist in Love2D, which is another reason why the plugin is super nice to have. I'll say .rectangle, and then if I press parentheses, you'll note that it also knows what parameters those functions should expect. So it says here, again, to reiterate, mode, X, Y, width, height. So I'll pass it in, for example, fill as the mode. It can be either line or fill. Fill being, it should be a filled in rectangle. Line meaning it should be a line rectangle, so just an outline. If I say fill, and then I'll pass in, let's say 0, 0 to get started. And let's say I want it to be, 100 by 100 pixels in width and height. And I save this. And then I rerun this code. You'll indeed see that we have a white 100 pixel by 100 pixel rectangle now being drawn at the top left of the screen, which is pretty cool. So we not only just have the ability to draw text onto the screen, but we can also draw shapes as well. And as you might expect, us sort of changing these XY values has the end result really of us being able to manipulate the rectangle moving around the screen, perhaps in real time, which we'll get into very shortly here. Now, of course, it's one thing to have just a static rectangle being drawn onto the screen, and another thing to have the idea of a paddle that should be able to move around on the screen, and the data being a little bit better encapsulated in that sense. So what I want to do is I'm going to keep this rectangle function drawn here at the bottom, but I want to come up to the top of the code here underneath where I've defined push, and I want to say something like, let's say player 1 is equal to curly bracket, so open curly bracket, close curly bracket. And if you're on in VS Code, by default, it'll close the curly bracket for you, so you can just hit curly bracket, enter. These curly brackets are what's called a table in Lua. So tables are extremely important. They are really the only data type you have beyond, numbers and strings that lets you do things like contain composite data. So if you, for example, done anything in C with structs, or if you've done anything with dictionaries in Python or objects in JavaScript, it's the same exact thing. You have a set of curly brackets within which you can say, for example, let's say I want my player 1 to have an X position. I can say X is equal to 10, for example. And I want it to have a Y as well. I can say Y is equal to 10. Notice that they are comma separated, and I'm using the equal sign to map this sort of X key to the 10 value. So if you were in, for example, JavaScript or Python, this might instead be a colon instead of an equal sign. But in Lua, this is going to be X equals or something equals something to be your key equals value pair definitions within player 1. Looking at the chat here for just a second, Charles asks, I don't understand what push start and push finish do. What basically those do underneath the hood is they draw to a sort of 384 by 216 canvas that push has allocated, and then push takes that canvas and stretches it to fill the 1280 by 720p window that we've defined. No need to really understand the technical details of what's going on, but that is effectively what push start and push finish does. It basically says, all right, right now we're going to draw up to our virtual resolution, which is going to get mapped to our physical window, and then we're going to stop doing that. So this is just something that push needs in order to properly work in our game. So yeah, no need to really understand the technical know-how. Just know that at least for it to work magically, whenever you do any drawing, push start needs to happen, and then when you're done drawing, push finish needs to happen. So good question. All right, is indentation necessary in Lua? Absolutely not. In fact, you could do something like this in your if statement. You could say all on one line, if key is equal to escape, then love.quit end, love.event.quit end, all on one line. The only thing that's important is that you have the keywords in the right spot, and the keywords obviously need to be space separated. But no, indentation is not crucial. It does not have semantic value like it does in Python, which Python obviously all white space is important. In Lua, it is not important. But the if and the then and the end, these serve to be where your semantic sort of differentiation of pieces of logic exist, if that makes sense. What's the keyword for reducing or increasing indentation for many lines of code? If you're talking about shortcut, that'll be, you want to highlight everything and you can use tab to do so in VS Code, or shift tab to bring it backwards. All right, just looking at the chat. Do you use a colon for all libraries and a dot for the other things? Not necessarily, but the way that push is implemented using what are called meta tables as a technical detail, it requires the colon operator to work correctly. All right. Just looking at all comments here. Okay, I'm not gonna go up too far. I know there's quite a few comments there. I apologize if I missed your comment. If you've said something to me that I've missed, I apologize. But that is, but I will do my best to catch up. And do repeat if I haven't missed, if it's a question that the mentors are unable to answer or the like. And if still not, then I do apologize. Somebody asked, can Lua utilize functional programming? Certainly, yeah. You would just make sure that you create new. If you wanted to properly use functional programming, you would create, whenever you do an operation, a new object that you return from the function rather than manipulate existing objects. Because functional programming, for those familiar, this is more an advanced topic, does not really allow you to manipulate state. That's sort of a key tenet of it. So you can't, for example, manipulate a global like this player one value. You would define a new player one, given it as a parameter, and then you would change the value within a new variable within that function, and then you would just return that new variable from the function. No need for folks unfamiliar, because that's particularly an advanced topic. But yes, you certainly could do functional programming. It's not well optimized for it in the same sense that I think other languages are optimized for functional programming. But it certainly, as a language that has first order functions, which Lua does have, it does have higher order and first class functions. You can utilize functional programming. Absolutely. If you take the course that I teach, GD50, we do utilize a lot of these functional programming ideas, or at least higher order function related ideas in the Pokemon lecture specifically. So yeah, do check that out. All right. So now we have a player one. We have an x is equal to 10, y is equal to 10. I want to do a couple of additional things. I want to say something like paddle width is equal to, let's say, 8 up at the top. This is a constant, just like all of the other things. So that's why it has the capital syntax there. And then I'm also going to say paddle height is equal to, let's say, for example, 32. So my height is effectively 4 times my width. If I save this, and let's come down to the rectangle function. Now you can kind of maybe anticipate where I'm going with this, but instead of 0, 0, 100, 100, which are sort of these static numbers, if I say player one dot being the operator to get access to a table key, a table value rather, to reference a table key, player one dot x basically says, what's my player one, what is the x key mapped to? In the case of our player one object, it's of course the number 10. So player one dot x, player one dot y. And then instead of the 100, 100, well, I know I have the paddle width and paddle height variables that I had created just a moment ago. If I save this and rerun it, you can indeed see at the top left of the screen now we have what looks very similar to the paddle we saw in our other image. We have a paddle that's 10 pixels by 10 pixels from the top left side of the screen. As a brief aside, important thing to note, all objects in Love2D are drawn by their top left corner. So we are 10 pixels out by 10 pixels out, and then this rectangle gets drawn at 0. Its own sort of 0, 0 is its top left corner right here, and then it's 8 pixels wide by, of course, 32 pixels tall. So all objects are drawn by their top left corner. So given the two offsets there, the 10, 10, and then the width and the height, we have effectively encapsulated our player one as an object with its own x and a y with a global set of values for width and height, and we are now drawing those all to the screen. So we've begun our work towards a game state, a global game state, which we will work on manipulating here very shortly. But actually, we're going to take a few minutes now as an exercise. What I want everybody to do is, if we take a look back at our slides, let's go back to the seminar slide here. Whoops, I don't want to do that. If we look here at this sort of spoiler for what Pong will look like in the future, we have player one here at the top left, but we also have player two at the bottom right. I want to take about 5 to 10 minutes now for folks on their own to implement the player two, and then have that get drawn to the screen as well. So we should not only have, by the time this is finished, the paddle up at the top left here, but also at the bottom right, same offset, but from the bottom right corner, the player two object. So why don't we take a few minutes to do that, and I'll be back in just a few to discuss how to implement that. So good luck, have fun, and I will see all of you in just a few. All right, so hopefully folks were able to tackle that a little bit, and hopefully that was a nice break for folks to maybe catch up a little bit if they were having some issues getting things working on their machine. I'm going to go ahead and, well, first I'm going to look at the chat just to see if there's anything that I missed, not related to folks chatting together. There's quite a bit of chat, which I'm super, super happy to see. So thanks everybody for being so interactive and for engaging and helping everybody out. This means a tremendous amount to me and the other teaching staff. Obviously, you guys are all a fantastic community. I am just briefly looking to make sure I didn't miss too much. All right. I apologize if you've tried to get my attention and have said something and I have missed what you've said. Again, do try to reach out if it's a question that you think I can answer that's not too technical or too setup oriented, and I'll do my best to catch it. Jack says NES graphics for life. Yes, I concur, for the sake of at least all of these sort of more old school style games. But so we had the challenge, recall, of creating the second paddle, the player 2 paddle, and it's essentially going to be a copy of the code that we've already written. So what we're going to do is up at the very top of the screen, we'll say player 2, not player 1, equals a new table that's going to get its own X and Y value. Now the X and the Y value are not going to be 10 and 10 because that would of course draw the rectangle at the top left again, which we don't want. We instead want the X to be bottom right, or rather at least X, we want it to be far to the right. So what we can do is we can say, we'll take the virtual width, right, which will put it all the way to the right side of the screen. Then we'll subtract that by 10, right, which is the offset that we had for player 1. Now, an additional thing that we need to do is also shift it relative to the size of the paddle, because recall, everything gets drawn by its top left corner. So if we just subtract 10, it's going to still draw the rectangle, it's going to draw the rectangle 10 pixels from the right hand side of the screen, but the paddle itself is 8 pixels wide. So it's going to be essentially just 2 pixels away from the right edge. To compensate for this, we just minus the paddle width as well. If folks ran into that issue while they were writing the player 2 code, that is the sort of way to remedy that. And the same thing is true for Y. If we say virtual Y is equal to the virtual height, so bottom of the screen minus 10, also minus the paddle height to accommodate that height, because recall it's drawn relative to its top left corner. That is how we can get our paddle to be drawn in the correct location. And then in addition to that, we need to add another rectangle call. So we'll say love.graphics.rectangle, which takes in fill, not player 1 and player 1.x and player 1.y, but rather player 2.x, player 2.y. And we can reuse those same paddle width and paddle height variables because they hold true for both paddles, not just player 1. And if we rerun this code, we do indeed see that at the bottom right of the screen, we have player 2 being rendered. Now, hopefully folks were able to follow along or at least understand most of that so far. And if I'm going a little bit too fast, I do apologize. Do feel free to rewatch a lot of this stuff, especially as we carry on. If a lot of this is unfamiliar or uncomfortable, certainly for folks brand new to programming, this can be a lot of information. So don't feel bad if you have to rewatch it or redo it or spend some time thinking about it. It's completely normal to feel that way, to experience that, especially with a brand new programming language like Lua and some new syntax and new terminology. Now, the thing about the current window is that this color, this really pure dark black on the pure white, it's a bit harsh. What I kind of want to do is change that background color a little bit. If you look at my seminar code or a seminar slide here, you can see that the background color is a little bit lighter. It's kind of like a dark grayish blue. So what I want to do is really kind of change that whole background color to be a different color. Now, I already have in some prior code the exact color that I want to change it to because I don't remember the color offhand. But if I cheat for just a second, and then I come over to here, I'm going to just copy this code. This is from another iteration of the seminar. But if I grab that line of code, I'm just going to paste it and then give a second so that folks can type it. But I'm going to paste it right above where I draw the rectangles. This function called love.graphics.clear. So what it does is exactly what the name suggests. It clears the screen, but it takes in a set of numbers that map to colors. If folks are familiar, These are RGBA components. Now, folks might be familiar with the idea of RGB color, RGBA color, given other contexts. But Photoshop, for example, uses this, and CSS on the web uses this, and even CS50 uses this when we talk about images. But these components are essentially numbers that map to, when combined together, light values that turn into color that we see on our monitor. So red, R for red, G for green, blue for blue, and then A for alpha, alpha being sort of a transparency level. Now, behind the scenes, Love expects these to be numbers between 0 and 1, but that's not as human readable or as human intuitive as these values. If we consider that an RGB value, an RGB or A value, can be any number between 0 and 255, they're 8-bit values. So in order to convert them from the number values, which make more sense, especially if you're importing them from another program, to those 0 to 1 values, you can just divide by the upper limit on those numbers. So for example, 255, given that we can only have up to 255 as a possible number for these values, doing this will result in converting those numbers to a value between 0 and 1. So for example, 0 divided by 255 is going to be 0. 255 divided by 255 is going to be 1, and any number in between is going to be some floating point value, a value with a decimal point between 0 and 1. Note, for example, I want full opacity, no transparency on the alpha, so this is 255 by 255, or in other words, just 1, which has the equivalent value. So this converts a particular color that I found by sampling a Pong image somewhere on the internet a long time ago into the correct RGB value, which then love.graphics.clear is going to wipe our whole screen with. Save it, rerun it. You can see that indeed the background is not that harsh, dark, pure black color, which is 0000 RGBA, but rather, or 0001, but rather a sort of darkish blue color, which is a little easier on the eyes, at least in my personal opinion. Note that VS Code itself is kind of a similar color as well. And then Barney asks if we make the background transparent, is the base color pure black, so it mixes with black? Correct. That is correct. All right. Folks have asked, can we watch anytime on YouTube, or is it time limited? Nope, it's going to be on YouTube at any time. Not time limited. You can rewatch anytime. And Valerie kindly posted the Facebook and YouTube links there as well. All right, so that is how we get a nicer color onto the screen. Now, so far we've talked about the core, input and render pieces of the puzzle, but we haven't touched on update. Recall, if we look back at our diagram here, we do have an update game box right in the center, and this is arguably the most important piece of the entire puzzle. Every piece is very important and inextricable, but the update piece in particular has oftentimes most of the logic that we're concerned about, at least in the context of Love 2D, given that we're not writing a lot of primitive rendering stuff from scratch. So let's take care of that next piece of the puzzle. Now in Pong, you can move the paddles sort of vertically up and down, and we want to do the same exact thing. I want to be able to press a key, W or S, for example, to move the left paddle, and up or down to move the right paddle. Now, the catch is with love.key pressed, this only fires immediately when we press a key once, and then it only does that 1 frame's worth of logic. And for example, this if key is equal to escape, and then we can keep holding down escape, but it's not going to keep firing that love.event.quit function. It only executes love.key pressed immediately 1 time on that 1 frame. We need to use a different function that'll actually check to see, am I continuously pressing down this key, which will allow us to hold a key down and therefore move something a bit more smoothly. In order to accommodate this, we're going to need to use a function called if love.keyboard.isDown, which takes in another key, in this case, let's say W. Now, additionally, I want to check to see whether the key is down, but I also want logic in here to move the paddle by a certain amount or at a certain speed every frame. Now, the way that we typically do this in games or in real-time applications is, given the consideration that my computer might be really fast, it might be faster than yours, or vice versa, your computer might be much faster than mine, or your game console might be much faster than mine. If you're in a world where game consoles were different, typically game consoles are consistent and they know their own speed, so this isn't a consideration. But let's say our computers are at different speeds, and I want my speed, I want my paddle to move always the same speed as yours, even if I drop frames or you drop frames. We do this by this magical parameter that we've seen here in love.update, which gets passed to us automatically by love2d. It's called delta time. And what this is, and dt, delta time, what this is it's a value that measures how much time has passed between this frame and the last frame, which means that if I skipped a few frames, for example, this dt value is going to be larger. And if I haven't skipped any frames, it's going to be smaller. What this allows us to do is scale movement or any sort of values changing over time based on delta time, which means that given any two particular snapshots in frames, if we just multiply by some speed that delta time value, it will be the same amount of change between those two times. So for example, if I have a value or a variable called paddle speed, and let's say I want my paddle to move 140 pixels per second vertically, right? This is going to be a number of pixels per second. So delta time is speed in seconds, meaning it's going to be some fractional amount. It's going to be 0.0 something, right? Depending on how many frames have passed. Typically 17 milliseconds worth of a second. So I'm not sure what that is off the top of my head. I think it's 0.013, something of that, something similar to that. 0.133333 infinite. But basically what we can do is we can multiply this paddle speed by delta time. And given that love is going to know how many frames have passed, and this delta time is going to be, larger depending on if more frames have skipped, we can say if love.keyboard.isDownW. So in other words, if we are holding down the W key, we can say player1.y is equal to player1.y minus, player1.y minus paddle speed times delta time. So whether 1 frame has passed or 3 frames have passed or 10 frames have passed since the last time this was updated, this will be a larger value. Therefore, this paddle speed will be given a larger ratio of its 140. So if it was 1 frame, then it'll be a 60th of paddle speed. If it was 2 frames, it'll be a 30th of paddle speed, and so on and so forth, assuming a 60 frame per second frame rate. So anytime you do any sort of movement or interpolation, or a value needs to adjust to change depending on frames, you want to be multiplying by this delta time value that gets passed to us into the love.update function. DT depends on the output device. It's going to depend on your computer. It's going to depend on your computer. But yeah, effectively, yes. If your computer is drawing to an output display that's 240 frames or 144 frames or 60 frames, delta time will be a different value than if it were at 60 frames. Where do we assign a value to paddle speed? Up at the very top here, right underneath paddle width and height. I chose 140. This is going to be kind of up to taste. A higher value will obviously mean that it moves more depending on delta time. So this is an example of what's called tuning. If you ever heard of tuning, value tuning in game engines, tuning to make sure that something is fun and playable and balanced, that is an example of tuning. If I were to make this say 180 instead of 140, based on what I feel is more balanced, that would be an example of tuning. So that is indeed how delta time works. So apologies if this is a little bit fast. Certainly there's a lot to cover here. And this is going to be a lot of technical information for folks. But do feel free to rewatch if folks are a little bit lost. To reiterate, delta time is the amount of time in seconds from this frame and the last frame. So the difference between frames, delta time, the difference in time, it's going to be a fractional value. You want to essentially multiply that. Anytime you move something or manipulate a value or want to manipulate a value, just make sure you multiply delta time by that value. So right here, we're just basically saying player1.y is equal to player1.y, so itself minus paddle speed times delta time if we're pressing W. So remember, minusing on the y-axis is going to have the result of moving us upwards. And to go along with that, we want to say else if before the end. So else if just means, so if we're not pressing W, else if, so in other words, but also check if love.keyboard.isDown S, right, which is the the opposite of W, if you're using WASD movement, then player 1.y is equal to player 1.y plus paddle speed times delta time, right? So that allows us to check to see the opposite of W, the opposite of moving up, which is moving down. Notice that we are adding to player 1.y. So we are increasing y as we go down, or as we press S, and that has the result of moving the paddle down. Now, if I save this and rerun it, you can see indeed that if I press W and S, we are moving at 140 pixels per second. So by a second's worth of delta time, after a whole second has passed, we should have added up to 140 pixels worth of movement if we've pressed W or S down for that entire second. So we're moving at about 140 pixels per second. So Tony asks, how do we check for the arrow keys? Well, that is actually an excellent segue because we're going to take another break here for about 5 minutes or so to pose a challenge, which is to see, can folks get the player 2 paddle to work by using the up and down keys on the keyboard as well. So the goal being not only to have the left paddle move, but also make sure that the right hand paddle on the bottom right moves in accordance with pressing the up and down keys on your keyboard. So that'll be the next challenge. We'll take a few minutes here to do that, and then I'll be back to show all of you the implementation. So good luck, have fun. See you in just a few. All right, hope folks had an easy enough time with that one. I know that this particular bit of code here has kind of a lot of stuff going on, especially with DT. I do apologize if some folks have gotten a little bit lost as a result of that. Effectively, somebody mentioned in the chat DT is kind of a downward multiplier for the speed, which we've defined up here, this 140. And yeah, that's a good way to think about it. It's kind of like a way of knowing that, okay, I want to move 140 pixels per second. But if I were to move by just paddle speed every frame, which this literally happens every single frame, if you just moved 140 every frame, you'd move off the screen very quickly. You might not even hardly see it happen. So DT effectively allows us to trim this down to that 140 over 60 frames essentially. But it takes care of also making sure that given different frame rates, different droppings of frames, that this happens smoothly and consistently across different platforms. So that's effectively how you can think of DT in a nutshell. Even if you don't properly understand all of the technical goings on, just think of DT as a downward scalar for a downwards scalar for something that we want to move over time. So in this case, paddle speed. So to complete the picture here, I'm just going to go ahead and code out what the assignment was for a little brief period, which was to make sure the right paddle moves according to input, in this case, the up and down keys. So we can say if love.keyboard.isDown, taking in literally the string up, which maps to the up key. And somebody asked how to figure out keys on the keyboard in Love2D. And I do believe this is in the love.keyboard class or namespace here somewhere. Yeah, key constant right here in the enum section. You can see all of them listed out. There's quite a few up here. So very feature rich. But indeed, if we look right here in the navigation keys, we can see up, down, right, left, home, end, page up, and page down. So there's a reference here. You want to look at the key constant page. And I just happen to know just from memory that that the up and down keys are the keys that we care about here. So I'm just going to say if love.keyboard.isDown up, else if love.keyboard.isDown down, then writing out the conditions before the actual code itself, I'm going to say player2.y is equal to player2.y minus paddle speed times the delta time. And then I'm going to say player2.y is equal to player2.y plus paddle speed times delta time. So increasing the y when we've got the down key pressed and decreasing the y when we have the up key pressed, making sure, of course, to multiply paddle speed by the delta time parameter. And if we run this and I press up and down on my keyboard, I indeed am able to move the paddle, and I can move the left paddle at the same time because both of these operations both happen in separate if blocks within the update function, one after the other each frame. So we can move both of the players simultaneously if we wish. Can we use ASCII to refer to a key? I'm not sure. I don't think so. I think these are all strings in Love. But I haven't tested, so you might want to try that out. I'm not 100% sure. Good question. Thanks, Valerie, for putting the key constant link there in the wiki as well. Okay. Just making sure I'm looking at the chat here a little bit. What would happen if I use two different love.update functions instead of just one? So it will overwrite the former with the latter is my understanding. Been a while since I have tested that, but it should just simply overwrite the love.update function with whichever one is located further down. Since Lua will be parsing your file top to bottom. Typically, this isn't allowed in a language like C or Java. It'll give you a compile error. But in Lua, I do believe it lets you override functions, and in which case they'll just take whatever the most recent value is. All right. How can we avoid having the player go outside of the window's size? We won't be covering that specifically in this seminar, but it's really actually relatively straightforward. You just make sure that when you do the operation of moving Y for either character, that you avoid player1.y going less than 0, which would be the top of the screen, and avoid it going beyond virtual width minus paddle height, which would be the bottom of the screen offset by the height of the paddle, such that it accommodates its height. Given the fact that the paddles are relative to the top left corner, we want to check to see not whether it's equal to virtual height, which would be at the very bottom, which would be the point at which the paddle's all the way below the top bottom of the screen. It would be when the paddle is right at the the point at which its height is above the bottom of the screen, if that makes sense. That's when its bottom edge would be essentially flush with the screen. And you could do all of that maybe as an exercise to the viewer. You could certainly do that here in your update function. So now we have the essentially core of the movement, all of the input that we care about in our game. The next thing that we want to do is talk about this idea of state. So the gist of Pong is relatively straightforward. We have a set of paddles that we can move. We have a ball that we haven't coded yet, but we'll get into very shortly. And then we have what's called a set of game states that are going to change the behavior of sort of what we do, or what's happening on the screen at once. Here's an example of what a state machine. So what a state machine is, and a diagram of what it would look like if we were playing something like, or trying to represent it for something like Mario. A state machine is really just a set of states, conditions, for example, standing or jumping or diving or ducking, sort of a state of existence, and their transitions. So for example, if we're standing and we press B, this transition marked by this arrow leads to jumping. So if we press B, we'll go from the standing state to the jumping state. That's one set of two states and one transition. If we're in the jumping state and we press down, we'll go from the jumping state to the diving state. So that's two more states with their own transition. And you can see how this maps to an entire set of states and transitions for something like Mario. The same logic, the same idea applies to a game as a whole. So for example, if I go back to my slides and we look at this, we see that we're kind of in like this title state, right? We have the title of pre-50 Pong, the ball's right in the center, the scores are set in the middle at 0. Our paddles are initialized to their default starting positions, and it says we should press enter. Now, if we press enter, we're going to go from the title state to what's called the serve state, ideally, which means that now it's going to wait for us to press enter again. It's going to say press enter to serve. And then once we do that, once we press enter, we'll transition to the play state, at which point the ball is going to start moving. We can move the paddles around to hit the ball back to each other. And then whichever person fails to hit the ball back to the other person is going to lose a point, or the other person rather will gain a point. And this goes on 10 times or however many times you want, over and over again, until we have a winner, until somebody has gotten the point cap for the game. At which time we go from the play or serve state to the win state, or the game over state. And then from the game over state, we can press enter one more time to go back to the title state. And then the whole cycle gets effectively repeated over and over again, at which point we'll have a complete game. That's essentially how game states will look, how our completed state diagram will look conceptually. We don't have any states yet, or any sort of implementation as to how to even begin doing that, but that is what we're going to have to now begin considering as we start implementing things like ball movement, like the title screen, and so on and so forth. Before we get into that, why don't we take a second to actually set up probably the key missing piece right now, which is the ball not existing whatsoever. So let me just make sure that I'm looking at the chat here, make sure I haven't missed too much. Okay. If push.lua is not working because it's trying to index self, that means you have not used the colon. Make sure you're using push colon, not push dot. That will cause issues. All right. Love.draw is called once. Love.draw is called every frame, once every 60th of a second after love.update, correct. Why do you use colon and not dot? That is a complicated topic. It's a Lua specific thing. It has to deal with this thing called a meta table, which is how you can get essentially objects to work, sort of like an object-oriented programming style in Lua, similar to JavaScript. And it's a little bit too technical to get into here, but feel free to look up Lua metatables, Lua object-oriented programming. And as an aside, I didn't mention this previously, but there is a Lua programming manual that you can look up online. Whoops, programming manual. So I'm gonna copy it into the chat. If folks are curious, this will allow folks to sort of look up some syntax related stuff. If you want to figure out a bit more about Lua, how it works, this goes into obviously a lot more detail. Meta tables and meta methods are, for example, relevant to what we were just talking about with colons. using this idea of a self object, which basically is how you can get objects to work, sort of object-oriented programming to work. Using dot versus colon basically prevents you from having to use self explicitly. It knows which object is passing in self, because colon passes in self automatically. It's nothing that anybody needs to know for the sake of this seminar, but certainly do look up some more of that if you're conceptually interested in a bit more of the technical goings on of Lua and how to get object-oriented programming to work in that domain. But transitioning back to Love2D and to the game, the key missing component right now is the ball. The ball currently does not exist. And a simple thing that we can do is mimic how we've set up the paddles by saying something like ball below player 1 and player 2 is equal to a table that has its own x and its own y. Now, I want the ball to be right in the middle of the screen. And so an easy way to do this would just be to say virtual width divided by 2. But since everything is drawn relative to its top left corner, this will have the result of the ball being slightly offset to the right. So to accommodate this, we're going to shift it to the left by half of its width. So it'll be overlapping basically the left and the right half, meaning it's perfectly centered. So we'll say virtual width divided by 2 minus, and then we haven't defined the size of the ball yet. So I'll say something like ball size is equal to 4. And then I'll say ball size divided by 2 is what we should offset the x by once we've gone to virtual width divided by 2. And same thing for y. We'll say y is equal to virtual height divided by 2 minus the ball size divided by 2 as well. And since the ball is going to be square, it's going to be symmetrical, we don't need a separate width and a height. Just a single variable to represent our size is good enough. And the last piece, of course, would be to come down here into our draw function. So we have the ball defined as a table, x and a y, divided by 2 minus the ball size divided by 2. So it's right in the center of the screen. We'll come down here and draw it. So we'll say love.graphics.rectangle. Pass in fill, player, or not player, but rather ball.x, ball.y, and give it the ball size and ball size. So assuming that we've coded this correctly and I run the program, we should now see the ball being rendered right here in the middle. Not very dynamic, not super interesting. It's essentially just a rectangle, a static rectangle like we were drawing previously. But this is the first step towards us moving to the ball being able to move on the screen, which, as some might be able to suppose, that logic will of course go into the love.update, making sure that we use DT to accomplish this, which we'll talk about in just a moment. Let me make sure that I am looking at the chat here. So is the ball size subjective? Yep, absolutely. You can make it however large, 5, 10 pixels. It's going to be obviously more challenging the smaller the ball is. So if it's a larger ball, it'd be easier to collide with the paddles. Once we get into collision detection, you'll see how that is implemented. But certainly, yeah, that detail, most of everything related to this is subjective. That's essentially the beauty of games and aesthetics, is that you could make everything whatever size and shape and what have you, whatever you desire. So yeah, so we have the ball now being drawn to the screen, but it is not currently moving. So I think still, even before we get to state, which is coming up soon, game state, we want to have a title state, want to have a play state to illustrate these things. I think what I want to do is at least get the ball moving, literally speaking. I want the ball to move on the screen. And once we have the ball moving, then we can actually split our state up into multiple states and manage that appropriately. But let's actually start moving the ball. So we know, for example, that in order to move the paddles, we can check to see in love.update, okay, is the keyboard, are we pressing W, are we pressing S, or up or down? And if so, we should move our Y value. Now, the ball is going to be able to move in multiple different directions. It can move diagonally this way, this way, this way, what have you. Basically, it has not just a Y velocity that it can move, like the paddle, but an X velocity as well. It has two separate velocities that we need to keep track of, such that it can move in different directions. If it has a negative X and a negative Y, well, it's going to be moving to the top left. And if it has a positive X and a positive Y, well, it's going to be moving to the bottom right. Because again, positive is going right and down, negative is going left and up, X and Y sort of correlatively. So to accomplish this goal of having these velocity values that are being managed, now we're not checking to see if anything's being pressed down. We just need to basically keep track of these velocities and basically always update the ball with them, I'm just going to add these new velocities to the ball. I'm just going to say dx, which is sort of like a shorthand for x velocity. I'm gonna say that the dx for now, let's just say it's 0, and dy should be equal to 0. Now, additionally, I want this velocity. I don't want this velocity to be the same thing every time, because if it is, I'm always going to know, for example, that okay, the ball's going to start going, this particular vector or this particular vector, right? Every single time. We don't want that to be the case. We want this to be random. We want this to change every time we start the game, so we don't know what to expect. So we can, it'll be a little bit more dynamic, a little bit more fun. So to have a dynamic velocity, we're going to have to start getting into random number generation. And if folks are familiar with games, you've probably heard the term RNG, or random number generation. And that's sort of what this ties into. Before we get into random number generation, though, we have to do what's called seeding the random number generator. Because the catch with random numbers is that they're actually not random, technically speaking. They follow an algorithm that determines something that feels random, that follows some sort of normal distribution, but is actually just a mathematical operation on some initial number that gives us a number that makes it feel like it's random, like it's not really coming from anywhere meaningful. So in order to do this, we kind of just have to do some little function call here that's almost rote, that we just kind of assume exists at the beginning of a program that uses random number generation in Lua. And that's this thing called math.randomSeed. Now what this does is it basically uses this math namespace, this math box of functions that exists in Lua. This isn't a Love thing, this is a Lua thing. We say math.randomSeed. So we're going to seed, that is give an initial value to, so that it can basically, so that it can grow, so it can give us more values. We give an initial seed value to the random number generation, and we pass in a value to act as that seed. Now, we want this to be a different value every time we start the game. So what we do is we use another namespace called OS, another sort of set of functions, and we use os.time. And what os.time does is that it takes the exact time right now in milliseconds, which is always going to be different every time we run the program, and we pass that into our random seed function. So math.randomSeed, which takes in our current time in milliseconds, will always guarantee that we have a different number, random number generation process from the beginning of our application until the end, even if we restart the game over and over and over again. So what I want to do using this is now actually use those random numbers to seed our ball's initial velocity. So in love.load, I'm just going to give it an initial velocity, and then we're going to take that velocity and run with it. We're just going to let it update the ball and just go on, basically. So we'll say ball.dx. I want to give it a random delta x velocity. So some random number. We'll say math.random. So this is going to give us a random number between 1 and whatever we put inside the parentheses here. So let's say between 1 and 60. So it could be between 1 and 60. Same thing with delta y. Let's say math.random 60. Now, some folks might anticipate that given that we are only passing in a value between 1 and 60, well, this is always going to be a positive x velocity. This is always going to be a positive y velocity. That's not really going to be super random. It's always going to be some down to the right vector, but at maybe different slopes, admittedly. We can correct this. We can say, okay, not only do I want to generate a random number between 1 and 60 and give it to the delta x and a delta y, I also want that to be a 50% chance of it to be a negative number as well. And to do this, we can use the same function, math.random. We'll say if math.random2, so random value between 1 and 2, so effectively the equivalent of a coin flip. If math.random2 is equal to 1, either 1 or 2, so it can only be one or the other, then we'll just say ball.dx is equal to negative ball.dx. Same thing for ball.dy. We'll say if math.random2 is equal to 1, then ball.dy is equal to ball.dy. So we basically give it a random number between 1 and 60, and then for each axis, we also flip a coin. And if it's the case that it's 1, so if it's heads, it's negative. Same thing for the negative delta y. And therefore, we essentially have a possible vector in all 4 directions, going up right, up left, down left, and down right in various slopes. So let me just look at the chat here. What's the ball instruction in love.draw? That was to draw the love, the ball in the center of the screen. So we're drawing a ball.x and ball.y, and then we have the ball size as the x, or as the width and the height parameter. So there, now we've initialized our balls our delta x and delta y, our x and y velocities. So now our ball has this value, consistent value for its x and y to move in those directions at that speed, right, over time. The next piece, of course, is going to be, okay, we have our velocity, but in order to use our velocity, we have to actually update our ball's physical x and y, because we're not using this dx and dy anywhere. It's just a number being stored on our ball. All we're doing is we're drawing the x and the y of the ball. So we need to update the x and the y given the delta x and the delta y. So in order to accomplish this, this is a perfect thing for our perfect use case for our update function, love.update. Because recall, anytime we move something, we should scale it by delta time. So you can think in terms of, if you need to scale something by delta time, if it's moving, probably belongs in your update function. So accordingly, we'll go down below where we check for input for our moving our paddles, and we'll just say ball.x is equal to ball.x plus our ball.dy or dx times the delta time, right? Because we are taking that delta x, but we're also multiplying it by delta time. Same thing for y. We'll say ball.y is equal to ball.y plus ball.dy times delta time. And if whether the delta x is negative or positive, this addition will work correctly. Doesn't matter whether it's negative or positive. It'll have the result that we are looking for. Now, if I save and then run what we have just written, you'll indeed see that the ball began in an upward trajectory, and it was obviously much higher negative y velocity than it was a positive x velocity, but it was just that. It was a negative y velocity, hence why it was going up, with a positive x velocity. Noted that it was going towards the right. If I run it again, you'll see that in this case, it was an extremely small x velocity, but a negative x velocity and a positive y velocity. So now we have the ability to randomly give our ball an initial velocity that goes in different random directions. The catch being currently that there's a chance that our velocity is really low. It could potentially be as low as 1. And if we're doing 1 by delta time over the course of a long time, it can be pretty tough to draw, pretty tough to keep up with. You know, if it's only moving 1 pixel on the x axis per second, well, it's going to take a long time for it to get to the right hand side or left hand side of the screen. So the best course of action, honestly, here is to give us a minimum velocity. So in order to do this, I can just say, you know, rather than just a random number between 1 and 60, I can say ball.dx is going to be at least 60 plus math.random of 60. So it'll always be at least 60 with some additional amount that's random, and then it'll still be given a random amount. And then same thing for delta y, only I'm going to make this 30 because moving, you know, on the y-axis, there's less room. So it being faster has a bit more of an exaggerated effect if it's on the y-axis. We don't need to worry about that being the same or being quite as high. Charles is asking, how does the ball change when it hits a paddle? That's a great question. We will get into that before too long here. But first, we're going to probably our next big thing is going to be on game state here. But I want to just save this after making these minimum values 60 and 30. And then I want to save this and rerun it just to, oh, that was weird. It lagged there for just a moment. Let me try that one more time. There we go. So you can see now it starts off and it's much faster. It's much more akin to what you might expect if you were playing the actual Pong game, going, because it does start with an initial minimum velocity of 60 on the x and 30 on the y, given some additional random amount between 1 and 60. So it's not going to feel super sluggish when we start. It's going to always have at least some minimum flow. And this is another thing that's tunable. That's something that you could adjust yourself. If you feel like that's too fast or too slow, you could make this initial starting point or this randomized amount even some bigger or smaller value. Dx and dy are just the scalar speed, not the vector or velocity. So the ball is the same speed every game, but it'll still change direction. It won't be the same speed per se, because delta x and delta y could be higher or lower, but those do influence the vector of movement. Delta time is what allows you to scale that amount. But yeah, dx and dy change the direction and how fast it goes, basically. So the higher the dx, the faster it'll move, because that's essentially pixels per second on the x-axis that it moves per second, you can think of effectively. All right. So we now have the ball moving, which is a key, big, important step. The next step, of course, we finally got, finally got the ball moving, but now we kind of want the ball to not always move. We want to start the game off in a particular state, a title screen. We want to then go from the title screen to being able to play at our discretion, because when we launch the game right now, we sort of are immediately thrust into this, oh shoot, I don't even know what to do. Okay, I'm player two. I freaked out there a little bit, didn't have time to react. We want to have time. We want to be able to press enter to start the game when we want to be ready for it, to not have to, react so quickly to it. We want a screen, a pause, a break, and also a break in between point scoring, because when a point gets scored, we want a second to catch our breath and also get ready to serve the next ball. So these are various game states that we want to transition between, rather than just have this one state where the ball's moving and the paddles can move around. That's just one default state. It's not quite enough to be an entire game. So let's go ahead and start coding that. In order to do that, we want some variable that can encapsulate this idea of a state. So a state really can be as simple as game state equals title. And that's all I need. I just need something that can store some string, some means to differentiate between different states. So we'll say game state is equal to title. Now, if it is equal to title, well, we probably don't want the ball to move during the title screen. So if that's the case, I can come down here into update, right, where I have the movement of the ball. And I'll just say something as simple as if game state is equal to play, and only then should the ball's X and the Y get adjusted to move the ball, right? And if I do this and I run the game, well, the game state's not equal to play, it's equal to title. So the ball is just, it's in place, it's not moving. And this is ideal behavior, this is what we want. Now, there's not really a whole lot to show us that it's the title screen. So it'd be nice to say, okay, well, we're in the title screen, why don't we display a title? Why don't we display some large text on the screen? And to do that, well, we've printed so far to the screen before, but only with relatively small text. It'd be nice if there was a way for us to draw a larger text to the screen. And indeed there is, actually. Let's go up here to where we have these constants being defined. And let's just say, for example, I want to create a new font, a large font. And I'm going to use what's called love.graphics.newFont. It's a function in the graphics namespace. And I want it to be a 32 pixel font, not 16 or 14 or whatever the default is. And let's just say I want a small font as well, so I can change back to the small font. And we'll do that as well. We'll do love.graphics.newFont, and we'll make this one a 16 pixel font, so half the size approximately, right? So now we got these two font objects effectively. This is just something that Love gives us. It lets us make new fonts. You could even pass this in if you have a font file, you could do something like this, my custom font.ttf, if you have something like this on your file system, and make it whatever font that you want if you downloaded one from the internet. But by default, we're just going to use whatever Love gives us, which I think is Arial. And I'm just going to pass in the number. So if you don't pass in the name of the font, it'll just assume Arial, and we'll say this one's 32, this one's 16. Now I'm going to scroll all the way down past update, back down to draw. And I'm going to say, right above where we do all of the paddle rendering code, I'm going to say if game state is equal to title, then, and only then, I want to do love.graphics.setFont. So we have to basically tell Love, okay, now we're going to use a different font than what we were using before. We don't want to use the default. We want to use love.graphics that we want to use the large font that we created, for example, because this is going to be what we want to display as the title. So we'll say, we'll set the font to that large font object we created before, which was large font. Notice that it's capitalized to show that it's a constant, that it's not going to change. And we'll use love.graphics.printf, not print, because we want to actually center this text on the screen. We want to make it look a bit more presentable. And there's a function that love gives us called printf, which serves the purpose of doing just that. It lets us actually format text to fit whether we want it to be centered or left aligned or right aligned. Left aligned being obviously the default of print. We want to center align our text. So we'll use printf. Notice that when I hit parentheses here, we can see that there are a few parameters that it accepts, being text and x and y, just like print, but also it takes in a limit, which is sort of like a column size that you can think of if you were formatting this, like say in Word or something, and then the align type. So whether it's left aligned, right aligned, center aligned, using these parameters, let's say, for example, pre-50 Pong is the title I want to render. I want to start it at 0 on the X, right? Because I want to basically center it between the left side of the screen and the whole screen size as a column. So I start rendering on the left, and then I want to do maybe 10 pixels from the top, and I want to use the entire virtual width as our column size, right? So this is effectively the amount of space within which we will then apply the align type, which is going to be center. So we're going to center it within the column size of virtual width, starting at 0. So basically starting it at using the entire window as a column. We can then say love.graphics.set font, small font. I want to go back to using the small font after I render that. And then below that, sort of at the bottom of the screen, I want to say printf and then press enter. And then this will be again at 0 because we're going to use the screen size, starting at 0 and going virtual width. And then I'm going to make this be from the bottom, let's say virtual height rather, minus 32. So 32 pixels from the bottom, so pretty close to the bottom, and centered again. I'm going to render this, press enter, using the small font. And printf takes care of all the logic needed to make sure that no matter what font you're using and how many characters it's using and what size it is, it knows exactly how to correctly center the text on the screen. Now, if I go ahead and run this, by default, we start with the title being the game state. So if I run, oops, I made a mistake on line 82. So on line 82, it looks like I did not actually put in the virtual width as the column size. Do make sure you've included the column size here at the second to last parameter in both of these. I made a mistake of not including that. If I rerun it, you'll indeed see that we have pre-50 Pong and press enter rendered in the center of the screen at the top and the bottom accordingly. Now I can press enter all day, but it won't actually transition the state to play to make the ball move. So that's another thing that we have to take care of right now. But I'm going to quickly look at chat and see if there's anything that I missed. Why did I do minus 32? Just a sort of value that's larger than the size of the font, but still pretty close to the bottom of the screen, such that it's not completely touching the bottom of the screen, but it's slightly above it, just because it aesthetically looks kind of nice. That's just kind of a default value, or an arbitrary value that I chose that kind of makes sense. But you could certainly make this whatever you feel like. Okay. All right. So with that out of the way, we now, of course, want to be able to transition game state. So we have the title state, but we don't have a way to go from the title state, let's say, to the play state with any input. So this is easy enough. All we can really do, recall we wrote press enter in our text as a prompt to the user. If we go to our love.keyPressed function, we can do just that. We can basically do the same thing that we did for escape, but we'll say if the key is equal to enter, or the key is equal to return. Now this is important for Max, because Max, the enter key is return. We'll say game state is equal to play, right? And if I do that and I run the game, if I press enter, the ball immediately begins moving up to the top right edge of the screen. So nice and just the logic that we were hoping for. Now, of course, there is a state that we want to exist before we even get to play it, and that's to serve the ball. So what we're going to want to do is add that logic as well. So to serve the ball, it's really going to be the same kind of logic. But to do that, of course, we're going to want to have an additional bit of code here. So we want to say not if game is equal to title, but rather if game state is equal to serve, which we haven't made any logic yet to actually get us to the serve state. But assuming the serve state exists, right, I'm just going to copy basically this line, these two lines here that did the title, but I'm not going to use the large font. I'm going to use the small font. And then rather than saying pre-50 pong, I'm going to say press enter to serve. And I'm going to hit the exclamation point right there. And the same exact logic here, starting at 0 with virtual width as the column size and centering the code. If I then also making sure that I go into the love.keyPress logic here. I don't want to I don't want to just have logic to check for enter and then go straight to play. I probably want to determine whether I'm in the title state. And if I'm in the title state, I should probably go to serve. And then if I'm in the serve state, I should probably go to the play state. So how would I go about doing that? Well, that'll be an exercise for all of you. So using the same bits of code that we have so far, so we have the ability to check for the enter key being pressed, the game state's equal to being assigned to play, but we want some logic to basically say, okay, well, if we're in title, we should go to serve. And if we're in serve, then we should go to play. So we're kind of adding this extra state from title to serve. And this will be even more germane when we get into being able to go from play to serve, play to serve, play to serve here pretty soon. But for now, why don't we take an exercise chunk of time here to add some logic to see, okay, well, if we press enter when we're in the title screen, let's go to the serve state. And if we're in the serve state, let's go to the play state, right? I'll give you all a few minutes to try to implement that. And then when we come back, I will illustrate the implementation for that. So good luck, have fun, be back soon. All right, we're back to implement the serve state here. So recall that we are prompted to press enter to go from the title screen to normally what was the play state, but which we want to be the serve state. So again, this is behavior that belongs in our key pressed function since we're waiting for a single key press. So because this is also an enter key press, within our condition here, I'm just basically going to say if the game state is equal to title, then and only then should we go to the serve state. Likewise, else if the game state is equal to serve, then and only then should we go to the play state, just like so. And we do have the serve code here. So by this logic, once you press enter, once we're in the title state, we should see the press enter to serve message, followed then by another enter press, which will lead us into the ball moving based on what random velocity it acquired. So if I go ahead and start this, I made a syntax error on line 77, which if folks are having an issue troubleshooting, it does tell you where your syntax error is here. Notice that it says main.lua : and then 77 for me. And for you, this might show a different number depending on what your syntax error is. And then it gives you a clue. It says a then is expected near game state, which probably means I forgot to say then, which of course I did. So I said else if game state is equal to serve, and then I forgot to put then do the game state setting to play. Now if I run this, now it works. And if I press enter, we do see that the ball's still not moving, but it says press enter to serve. So now we are ready to serve the ball. We can get our paddles into position, press enter, and then the ball starts moving. And then theoretically, one would be able to start to try to anticipate where it's coming and play. Of course, there are several pieces still missing from this. For example, the fact that we don't have scores, and the fact that the ball doesn't bounce off of walls, and the fact that we don't check for points being scored on the left and the right, and that the ball doesn't bounce off of the paddles. These 4 pieces are the last 4 pieces really that we'll be taking into consideration as we go on for the next 40 minutes or so. So why don't we begin to tackle these things? I'm also going to look at the chat here for a second. So somebody asked if I could stay on the code for a couple of seconds before I scroll down. So sure, I'm going to go ahead and keep it here. Alternatively, just because we will have to move a little bit faster, I think, over the next 40 minutes or so, I'm going to repaste the link to the repo so that folks can peek ahead a little bit if they wish. And this will allow you to look at the seminar code from prior iterations. But again, don't worry too much if you're unable to follow along 100% in real time as we go along, just given that there are quite a lot of pieces. But you can certainly rewatch and follow along at your own pace going forward, and reference that code as well if there's a particular piece that you are unfamiliar with, since most of it as exists in that repo is going to closer match what we now have in the repo. So game is switching between states when I hit enter, but none of the text is showing up. Do make sure that game state, you're setting your game state properly to the correct string, whether it's title or serve. You're using the double equals, and then you have the conditional logic located in here, and you're doing it after, not before you call love.graphics.clear. Because if you call clear after all of this has happened, you won't actually see any of your stuff on the screen, because your code is effectively getting cleared right before this love.draw function finishes and outputs the content to the screen. So do make sure this clear function is happening at the very beginning once you do push start. All right. Cool. So I just mentioned score. So why don't we tackle score first? Score is a relatively straightforward thing to begin to implement. Since it's something that belongs kind of to the players, I'm just going to go ahead and literally to their tables, I'm going to add score, and I'm going to set them both to 0 as the default beginning value. Now, if I save this, I'm also need to, once you've added score to equals 0 to both tables, scroll to the very bottom down to where we have our drawing code here. And I'm going to always display the scores. Doesn't matter what state we're in. Pong always displays the scores. So just at the very bottom, I'm going to say love or first of all, what I'm going to do is I'm going to say love.graphics.setFont. I want these to be really large right in the center. I want them to be using the big font. So I'm going to say love.graphics.setFont to the large font that we created before. Then I'm going to say love.graphics.print. And then let's say player1.score, the number we just added to the player one. And then we'll say virtual width divided by 2. So roughly in the center, let's say minus 36 or so. These are just numbers that I've sort of figured out over time. And then let's make it about halfway down the screen by virtual height divided by 2. And then we'll say minus 16. So about half the height up above the middle of the screen of the text size effectively. And then we'll do the same thing here for player2.score, only instead of virtual width divided by 2 minus 36, we'll say virtual width divided by 2 plus 16. And then this takes in virtual height divided by 2 minus 16, because it's going to be in the same position vertically as the other score, but it's going to be offset further to the right, hence why we're doing virtual width divided by 2 plus 16 here. And these numbers are just numbers that roughly are about center oriented. So, and then the last thing that we want to do as well, before we finish that, right below you do, or where you have the 2 score calls being printed here, let's just do a love.graphics.setFont to the small font again. That way, in case we draw anything further later on in the code, it'll be the default small font. It won't be this large font, because love will basically remember forever until we set the font to something else, that we set the font to this large font here. So I'm going to save this. And then assuming that I have the numbers correct and everything, I'm going to go ahead and hit Alt-L. And indeed, we can see our 2 scores there right in the center of the screen. And if folks remember from the slides, that's essentially exactly what we have here. When I said this was our goal, literally, we have achieved that goal visually, at least in as far as the title screen is concerned. But we still have a ways to go left with some functionality in terms of collision before things work properly. So let me go ahead and take a look at the chat here. What's the difference between print and printf? Exactly as somebody mentioned, it just means that print lets you put things in a specific position, and printf will format things for you depending on whether you choose center or left aligned, right aligned. So in this particular instance, I chose to manually allocate where the 2 were located, just a little bit easier than figuring out how to get that working with printf. But you could certainly do that as well. If you right aligned and left aligned these 2 columns, you could certainly do that as well. All right. So hopefully folks followed along with that one. Just some relatively straightforward print calls. Now we're just managing a score variable on both player objects. We're going to be manipulating this score variable in order for us to obviously accrue points as we beat the other player and vice versa. But for right now, it's mainly just to act as a placeholder for when we get to that point. Once we serve the ball, right? Once we are ready to serve, rather, let's rerun our code. So we have our title screen, we have our serve state, that works fine. And then once we serve the ball, the next piece of the puzzle is, well, I should probably figure out, 1, whether it bounces off the walls, top and bottom, and 2, whether it goes past the left or the right edge of the screen. If it goes past the left or the right edge of the screen, well, that means that the opposite player of that edge just scored a point on that player, because if you get a point past your boundary, you effectively lose that round and the other person gets a point. So we want to check to see, okay, well, we can do this basically by saying, has our ball's x velocity, or not velocity, but has our ball's x position, rather, gone past the left or the right edge of the screen? And if so, well, just add a point to the opposite player. And a great place for this to be is in the update function, because we're checking, based on the ball's movement. And we can do that, and that really only should occur in the play state as well, since we already have this if condition here that says if the game state's equal to play, move the ball. We can go down below where we move the ball on the same frame and say, okay, has the ball gone past the, let's say, the left edge of the screen? So relatively straightforwardly, remembering that the ball's xy is relative to its left corner, we'll say if ball.x is less than or equal to 0, then this this is if player 1 loses the round, so player 2 dot score should be equal to player 2 dot score plus 1. Now, if you're coming from another language like C or C++ or Java or even Python, you probably are used to seeing, for example, player 2 dot score plus equals 1 or plus plus. Unfortunately, Lua does not have plus plus or plus equals or times equals or any composite assignment operator. You have to do a sort of redundant player 2 dot score or whatever. We did it up here with the y values when we did the checking for input, but you have to do this something equals something plus or times or minus some value. It's a little bit tedious, and it's one of Lua's maybe shortcomings, perhaps, but it's something you relatively get used to. It's not a huge deal. So we add one obviously to the player 2 score. Once we have done this, we also want to reinitialize the ball, right? Because if the ball goes to the left edge of the screen, well, we should probably set the ball back to the center. And we can do this pretty straightforwardly. Recall, if we go back up to the top of the screen where we actually create the ball, we have the X and the Y being set to the default center of the screen coordinates. Well, we'll just copy those, bring them down here, paste them in, right? Except now, because we're not in the table of the ball anymore, we have to be a little bit more explicit and say ball.x is equal to virtual width divided by height minus ball size divided by 2, and ball.y is equal to virtual height divided by 2 minus ball size divided by 2, and get rid of these commas since we're no longer in the table. This has the effect of putting our ball right into the center of the screen. And the last sort of piece of this puzzle, or one of the last pieces, we'll get into another piece pretty soon, is that we have the ball, the X and the Y get set to the center of the screen, but we're going to still be in the play state, which means that, well, right as soon as that happens, the ball is just going to shoot back in the direction that it was shooting before. We need to change the state back to serve. And somebody mentioned why we even need the serve state in the first place. Well, it's for this reason. Whenever a ball gets scored or a point gets scored on another player, we want a moment's reprieve to be able to say, okay, somebody scored a point, let's take a pause, let's reorient, and then let's reserve the ball. That's effectively the purpose of having the serve state. And so now we have the ability to go from the play state back to the serve state. And since we already have logic to go from serve to play when we press enter, well, now we have the effective ability to play over and over and over again from serve to play ad infinitum. So if I reset this and then wait for the ball to go to the left edge of the screen, which is going to do right here, even though it's below the screen, we do indeed see that a point got scored on the right-hand side. The ball got reverted back to the center. And if we press enter, we can now go back to the play state again. And of course, the ball is the same velocity. We're going to have to probably reset what that velocity is and randomly rechange it. But for now, we have at least the ability to go between the play and the serve state. Now, as an exercise, we obviously have the ability to check to see if the ball went past the left edge of the screen, but currently not the right edge of the screen. So let's take about 5 to 10 now and see if folks at home can implement the collision for the right side of the screen such that player 1 gets a point, and then the ball gets set, or the game state gets set to the serve state again. So let's take 5. We'll be back in just a few. All right, back to talk about how to check to see if player 1 scored on player 2. So hopefully folks were able to implement such. If not, no worries. We're getting into slightly more complicated territory. So do not feel discouraged if you're currently having a little bit of trouble following along. Sometimes it takes a couple iterations. But the code here is going to be very similar to what we just did with a couple of small caveats. So we can implement this by doing an else if. So right, if the ball is less than or equal to 0, do the code to check to see if player 2 scored on player 1, else if ball.x is greater than or equal to virtual width minus the ball size. Because remember, everything is relative to its top left corner. So by checking by checking less than the offset of the size of the ball, we are effectively allowing us to check to see that the right edge of our ball has touched the right edge of the screen. So if that's the case, we can then say player 1.score is equal to player 1.score plus 1. And then we'll do the same sort of bit of code here. I'm just going to copy and paste this because it's going to be the same bit of logic here. We're just going to reinitialize the ball right to the center, and then we're going to make sure that the game state gets set back to serve. Now, there's a little bit of redundancy here, and we can actually take a couple of seconds to accommodate for this. Somebody had mentioned in the chat that there was a need to reinitialize the randomized vector of the ball, the velocity of the ball, so that it doesn't go in the same direction every single time. And that's exactly something that we will need to do. But just real quick to make sure that we got this correct, I might have to rerun this several times depending on where the ball starts moving, but indeed moves right, and it works correctly. We have player 1 getting a point here as soon as the ball got past the right edge of the screen. And then we got set back to the serve state, and then we can press enter to go back to play. But of course, notice that it does indeed go in the same direction every single time, which is not ideal behavior. We want this to be random every time. Now, the nice thing is that we already have logic for initializing the random velocity of the ball. So the thing that we can do is simply copy our randomization. And let's take a second to make our own function for the first time. Let's pretend that we're gonna have a function and it's called reset ball, right? Doesn't exist yet, but we're gonna implement it right now. But basically, replace the logic of the ball velocities being randomized. So copy that, and then cut it out, replace it with reset ball, and go to the very bottom of the program. And we'll just say function reset ball. And we're just going to paste in that code we just copied, the randomization of our ball.dx and ball.dy from before. Additionally, resetting the ball also involves taking the xy and setting it right to the center of the screen. So what we can do is we can copy this code from right here, all the way to the bottom again, and just paste this right at the top as well. So now we have the x and the y getting initialized to the center, and the velocity getting initialized to a random value. So we can go back up, way back up here. And instead of having these lines of code that say ball.x and y is equal to the center, we can just replace this with reset ball in both of these circumstances. And now, not only have we sort of avoided a little bit of duplication of code in a couple of places, but since our reset ball function also handles the randomization of our dx and dy, we not only center our ball with reset ball, but we also re-randomize our velocity. So we've accomplished two things at once by cleaning up our code and lumping in our velocity randomization with our centering of the ball. So giving folks maybe a couple of seconds, I'll just reiterate that. You have these reset ball function calls here, and then also remember in love.load as well, we took our random velocity code from love.load and we pasted it in here, and we took our initializing the ball in the center code, put it in here, and then just replaced all instances thus far, the 3, with the reset ball function call. And then why don't we add changing the game state to the reset function? That is a interesting consideration. And the main reason really is that we have it up here in love.load, and we don't want the first start state of the game to be serve. We want it to be title. So explicitly, we're kind of keeping reset ball independent from the game state because that would kind of be biting off a little bit more than we should chew with the one function. It should really only have one purpose, which is to reset the ball, not necessarily to change what state of the ball that we're in. So good question though. Thank you for asking. So we have the reset ball function. I'm going to run this now. And if everything is correct, the ball should change its velocity after every point. So we start off going to the bottom right. Now it's going to the top left. Top left again, slightly lower slope, and then bottom left. So indeed, we have the randomization taken care of, and we have the resetting taken care of, all in one function, nice and encapsulated. So that piece of the puzzle has been cleanly bitten off. The next big thing that some folks probably have noticed, especially as we have just demoed that bit of code right there, is that we're not accounting for the fact that the ball should bounce off the top and the bottom of the screen. It's kind of weird that the ball is able to just kind of go out of bounds, which is definitely not at all how Pong works. The ball is only allowed to operate within the bounds of the screen window. So the way that we can accomplish this is by writing some logic that effectively does what we did with the left and the right side of the screen, but instead we'll actually check not the left and the right, but maybe the top and the bottom, and then do something to prevent the ball from going out of bounds. But of course, this is a perfect chance to test all that we've learned so far today, and maybe expand upon the logic that we used up here and update to see if the ball went past the left and the right edges of the screen. Why don't we use this as the final exercise for today, and certainly the most challenging. So don't feel discouraged if this feels a little bit insurmountable, but this will be the last challenge we do for the day. Make the ball bounce off the top and the bottom of the screen. We need to take into consideration our Y position, of course, and then perhaps our Y velocity. So let's give that a whirl. This will be our last challenge. We'll give about 5 to 10. When we come back, we'll talk about not only this, but also how to bounce the ball off of the paddles, and then we'll effectively have completed our game. And we'll talk also about checking for score, but that'll be a last sort of minor point. But until then, good luck, have fun. Be back in a few minutes. All right, so no worries if that was a bit much. Certainly that was the most challenging of the exercises we will have done today. So if you might need a little bit more time, or if you need to try again at a future time, totally understandable. There are a lot of pieces happening, a lot of interactive parts at this point in time with the game, and games are complex orchestrations. So no worries if it was challenging. But we'll cover it right now, and then certainly in the future, perhaps give it another blind try. But it's going to be very similar to what we did with the left and the right edges of the screen, only now we're going to be talking about the top and the bottom edges of the screen. And it'll be slightly different in that we're not stopping the game, and we're not going to effectively go back to any particular state. We're actually just going to change the behavior of the ball upon its interaction with the top and the bottom edges of the screen. So we can do this outside of the sort of if else of the ball.x being checked for the left and right edges of the screen, or yeah, for the left and right edges of the screen. We'll do it similarly by saying if ball.y is less than or equal to 0, else if ball.y is greater than or equal to virtual height minus ball size. Notice the parallel between this structure and this structure. The two conditions are very similar, but now of course we're checking for y, we're checking for height minus ball size, not virtual width minus ball size. And I'm not doing any score manipulation here, but rather when we change, or when we hit let's say the top of the screen, we're going up. Well, we want to go from going up to going down, and vice versa. When we hit the bottom of the screen, we want to go from going down to going up. And really what this is just a essentially toggle on our y velocity. We'll do is we'll say ball.y, rather ball.dy is equal to negative ball.dy. And actually it's the exact same in both circumstances. We're doing a negativization of the ball.dy. And you could actually put both these conditions on in one expression. You could say if ball's less than or equal to 0, or ball.y is greater than or equal to virtual height minus ball size. But for readability, we just split it into two separate conditions here. This is really the whole gist of it. It's actually relatively straightforward, but it can be a lot when you're taking in all of this at once, sort of blind. So now what we're going to do is say, oh, actually, and yeah, to Charles's point, the why do we do less than or equal to 0? Yeah, it actually should probably be, well, it depends. The goal kind of is to make it bounce off of the even when it's touching the edge, rather, and that's right when it touches the top edge. So less than or equal to 0 is appropriate. It works fine, but you could do less than or equal to 0, and then just make sure that no matter what, you're resetting your ball back to the edge of the screen. So ball.y should therefore be 0 immediately, and then ball.y should be this value immediately afterwards. Because if you don't reset your ball and you go beyond the edge of the screen, you're going to get infinitely stuck in the wall. And actually, you should still even do this now. But we're going to talk about that logic as it applies to the paddles in just a little bit, so we won't spend too much time on it right now. But yeah, both of those are valid implementations, but they will both perform or look the same. So we're going to go ahead and do this. I'm going to run this. We'll go into the serve state here, and indeed we do see the ball moving off of the top and the bottom edges of the screen. So things work as they should. We are flipping our velocity when we go above the screen and when we go below the screen. All right. So excellent questions. People are being very participative and helpful in the chat, so I do appreciate it very much. Thank you for everybody who is helping assist. Now, we have the balls bouncing off the top and the bottom, but the last piece of the puzzle, probably the most important piece, is collision detection between the paddle and the ball. So before we get into implementation, why don't we just conceptually try to understand what we're seeking to do here. So in the world of 2D games, in simple geometrical physical terms, we have the idea of what's called AABB collision detection, or axis aligned bounding boxes. Now, what this means is when you have two boxes that are orthogonal, completely orthogonal, and axis aligned, in other words, not rotated in any way, there is a simple formula to check to see whether two rectangles overlap. And that is to say that you just have to check to make sure that they're not separated on any axis. So if this blue rectangle, for example, is to the right of this green rectangle, if it's to the right edge of it, or the top edge of it, or to the left edge of it, or to the bottom edge of it, then we know that it's not a collision. It's not physically possible for them to be collided. So we just basically check to see, is the left edge of the blue past the right edge of the green? Is the top edge of the blue past the bottom edge of the green? Is the right edge of the blue past the left edge of the green? Is the bottom edge past the top edge of the green? If you do this for all 4 edges appropriately, you can basically determine whether or not you have a collision if you have any 2 rectangles. And that's effectively what we're going to do, except we're going to be treating it as the paddle and the ball. We're going to say, is the ball outside of any of the edges of the paddle? If it is, then it's not a collision, effectively. And then we can just write a function that encapsulates this. And then if we return true, like, oh, we do have a collision, well, then we need to do kind of what we just did for the top and the bottom of the screen, where we reset the balls dy, we flipped it, but we need to flip the balls dx instead. So why don't we go ahead and back to our text editor here. And let's take a look at maybe how to write a collision function. So we're going to go down to the very bottom. I'm just going to write this above the reset ball. And we'll call this function collides. And we'll assume that it takes a paddle and a ball. Now, recall, we effectively just need to check, are we past any of the edges of the screen? Are we past, is the paddle or the ball on the opposite edge of any of the other rectangle, the paddle or the ball, conversely? So what we can do is we can basically write out those expressions. We'll say, okay, so paddle dot x being greater than ball dot x plus ball size, right? Because remember, we're checking basically here, okay, is the paddle's left side beyond the right side of the ball? To get the right side of the ball, we have to make sure we add ball size, because remember, x is relative to its left corner. But if you do x plus ball size, that'll be the right side of the ball. So we're saying, is the paddle to the right of the ball, basically? Or let's say paddle dot y greater than the ball dot y plus ball size. This is checking to see whether the paddle's y is below the ball, right? Because y plus ball size is going to be the bottom edge of the ball, right? We need to do the same thing with the other. We need to flip it around basically and check to see, okay, how about we check to see whether the ball's x is greater than the paddle's x plus paddle width, right? This will check to see whether the ball is to the right of the paddle. And then conversely, on the y side of things, if the b dot y is greater than p dot y plus paddle height, well, that's checking to see whether the ball is below the paddle, right? So we've checked to see whether they're to the left or right of each other and to the top or bottom of each other. But these will return, if these return true, well, then we know that there's not a collision, right? So we need to basically check to see whether this is not true to return whether they collides. Otherwise, this function would be called not collides. And that's kind of not intuitive. So what I'm going to do is I'm going to say, okay, let's return, that is, back to wherever we call this function, let's return the value of not this whole expression. So we're going to negate this whole expression. What that's going to end up doing is basically, if this returns true, any of these return true, meaning we do not have a collision, let's reverse that with not. Let's flip that, let's negate it Boolean wise, and this will therefore return true in the event that we have a collision. So a little bit complicated, maybe, if this is the first time you're looking at it. It's in the repo, as Valerie kindly posted. If folks are maybe having a little bit of a hard time following along with this, it certainly can be. The first time you take a look at it, the first time you write it out, essentially looking to see whether the rectangles are on the opposite side of one another. But visually look at it, try to make sense of it, and then maybe look at this code and try to understand what's going on here. And if so, eventually it will click. Certainly for me, I'm not super mathematically minded, so I have to kind of look at these things a few times before I fully understand what's going on. But it really is as simple as checking to see whether or not rectangles are not overlapping. So basically that's what we're doing. We're basically saying, are they not like outside of each other's bounds effectively? So we have this collides function, takes a paddle, takes a ball. We can then use it anywhere we want to. So if I were to go up to, let's say, our update function, and in our update function, sort of like right below where we have the code to check for whether we're bouncing off the walls, let's say, okay, if collides player 1 with the ball, right, then what we want to do is, okay, well, if player 1's colliding with the ball's going to be coming from the right, and we want to make it go back towards the right. It's going to be going left, and we want it to go back to the right. So what we can do is say, okay, well, we know that ball.dx is going to be negated in much the same way that ball's dy was negated previously. To flip its y direction, we're going to flip the x direction. So ball's dx is going to go from being negative in this case to being positive. In addition, we want to make sure that in case the rectangles got overlapped in that frame, in other words, the ball's dx is actually inside of the player's dx, which is going to be true if our collision function is being returning true. What we want to do is then say, okay, ball.x is going to be equal to, basically we're going to put it to the right edge of the paddle. So we'll say player1.x plus paddle width. So this will make sure the ball is completely flush with the paddle, not intersecting it, pushing it outside, basically, which you might have seen in various games. If you've collided with something and then you get pushed outside of it, whether it's a wall or another enemy or the like, this is what's happening. Your position is getting reset to be outside the bounds of that other collidable entity. And then we just do the same thing, but in the case of the ball of player 2 colliding with the ball, only ball.dx is going to be equal to negative ball.dx. Of course, in this case, the positive dx is going to flip negative, but ball.x is not going to be equal to player1.x. It's going to be equal to player2.x. And we're going to make sure that it gets kicked outside the bounds of the paddle. And to do that, because we're on the left side of the paddle, it's actually going to be whatever the size of the ball is that we're going to be shifting to the left. Because remember, this is relative to our ball's left-hand corner. So we're going to subtract by ball size, not adding paddle width like we did here, but rather shifting or subtracting our ball size from the paddle's position to perfectly put our ball such that it's touching that right side paddle. Now, if we do this, assuming that the collision function was written correctly, and this code was written correctly, and I run the code, and I try to bounce the ball back, we do indeed have the ball bouncing off the paddle on the right and the paddle on the left, and so on and so forth. So the core of the game really is complete, albeit without things like making sure that it speeds up over time, which we could certainly do by maybe multiplying the dx by something like 1.02 every time it collides, like this. This is a way that you could ramp up the difficulty over time. And we also haven't covered things like setting up a win state by making sure the score is greater than or equal to 10, which would certainly be relatively feasible. Maybe we'll leave that as an exercise to the viewer just because we are a little bit short on time, but as maybe a teaser for something like that, we could certainly do something like if let's see, it would be in the in this bit of code here, you'd want to say something like if player let's see, player 2 dot score is greater than or equal to 10, or whatever your score is, then you would set the game state equal to win. And then just like we've done many times before, you would make sure to have some win code, some win state code in your draw function and in your key press function to reset yourself and the score back to 0. We covered this when we had a little bit more time in the other seminars, if you want to rewatch those on YouTube. But we have hit the 3-hour mark, and I don't want to take up too many people's time. So we won't necessarily cover the details of that, because I also want to maybe cover some future sort of homework assignments, quote unquote, or features that you could add to this. But let me skim the chat just to make sure that I could that I don't miss anything too much. Okay, we got some nice comments from people. Does putting the collision detection above the top, bottom, left, right edge handling and update affect the performance of the game? Like maybe you want the ball to react faster in a collision with a paddle than in a collision with a wall. They should be any faster or slower because it's about the same amount of logic. if I'm properly understanding what you're asking. And then Valerie did post the code to the prior seminars, and this code will actually go live as well. And because there are going to be, because the win logic is actually going to be absent from this code, this would be a great maybe exercise is download this code, which will go live in maybe 10 minutes or so, or 10 or 20, however long. And then add the ability to have a win state to check to see whether the player's score is greater than or equal to 10 or 5 or whatever you decide it to be, and then change the state to win, and then from win back to title, making sure you reset the scores to 0 when you do, and you can cross-reference that with the other iterations of the seminars. Some optional additions you could make going forward if you wanted to take this even further. You could do some basic AI, which is what GD50, the course that I teach, does in the first homework assignment. We ask students to create a basic AI for the second paddle, which is a deceptively simple task because there are a lot of shortcomings you could run into with this if you did a sort of a naive approach of maybe, the first implementation that might come to mind with this. Image-based paddles instead of rectangles. So you get into love.graphics.draw, creating new images, new textures, using music, sprite backgrounds, multiple balls that all can trigger points for the opposite person to make things a little bit more hectic, perhaps. Paddles that you can grow in size, which we talk about in Breakout in GD50, maybe the ability to choose how many points you want to work towards before the game even begins. So we're getting into UI related things, and also maybe more advanced collision detection, because eventually if you keep speeding up your delta X, you will clip through the paddles. So having a form of collision detection that actually accounts for this could be a really advanced task to look forward to. So this was pre-CS50. I will look at chat to answer questions before we conclude the seminar here. Pre-CS50 games edition, I should say. And if you could also fill out this form, so this feedback form, I'll copy the link into the chat. We greatly appreciate any and all feedback. It helps us make the course and our course offshoots all the better. So do please submit that if you can. We would greatly appreciate it. And yeah, I'll take a few minutes here to look at chat and answer questions if anybody has questions before we properly conclude the seminar. So thanks to everybody for the kind feedback here at the end. I appreciate it very much. NES Graphics for Life, says Jack. Appreciate it. Thank you. Dennis, thank you for delivering such a great course, making it interactive and simple. Thank you very much for that and for tuning in. It's certainly my pleasure. I like games a lot. Can we dress up players by assigning 2D graphics? Absolutely, asks Maria. You would just need to maybe look into love.graphics.newimage, love.graphics.draw to see how you might go about doing that, or take GD50 where we talk about sprites and textures. And Valerie kindly linked to the edX version of the games course, which you absolutely can take and enroll in for free to get a lot more than just Pong. We go into Zelda and Mario and Pokemon and Unity and Portal and all sorts of fun games. So do check all of that out as well. Why do I like to teach in in Love 2D instead of Godot? Based on looking at Godot, the API is a bit easier to get into. With Love 2D, it's simple. Godot was a bit more work to get up and running. It's a larger framework. I don't remember if it's visual or not. I think it is a visual integrated environment as opposed to a code-based environment. It's been a long time since I've looked at Godot, to be fair. All right. Thanks so much, everybody. So many thank yous in the chat. I appreciate it very much. So many. I'm having a hard time keeping up. All right. Let's see, there's 48 messages in the time that I read all that. What are the main game development languages professionally? Probably C++. I mean, it kind of depends. Like C#, if you're in the world of Unity, is obviously very relevant, but C++ is sort of like the de facto industry standard for like console and higher end game development, I would say. But you can write games in just about any language using frameworks and using OpenGL wrappers and whatnot. So saying that there's only one game development language or a couple is kind of it's kind of a oversimplification of the landscape, for sure. Best platform to make games. For somebody new, I would point to something like Unity, but there's honestly so many awesome integrated environments for game development these days that you can honestly just sample everything. There are a ton of different things. Pranav, appreciate it on the concept, such a small time of 3 hours. There's a lot to cover. So again, I want to reiterate, if this seems like a lot to people, it is a lot. There's a lot that goes into game development, but if you followed along for the most part, kudos to you. And if not, don't feel bad. Definitely rewatch the video, re-look at the lectures, try to implement everything from scratch. You will in time come to be very comfortable if this is something that you enjoy. So do not feel discouraged in the slightest if this felt like a lot. It is a lot. The first time that I got into game development it felt like a lot to me too. Trust me. Do you need to learn assembly language programming for game development? No, not now, not anymore. That was a thing in the 70s and 80s and going into the 90s, arguably into the early 2000s for platforms like the PS3, but not anymore. It's interesting, but to be in the world of games, you do not need to learn assembly language. Pico 8. I think Pico 8 is pretty cool. I like the idea of it. Sort of like a purposefully limited, like a cool little super retro style platform for development. I like it. I think it's cool. I haven't done a lot on it. I think I downloaded it at one point a long time ago. I think folks actually made a version for Pico 8 in Love 2D. I could be misremembering. When is the Elder Scrolls 6 coming out? No idea. Wish I knew. What was the balloon screen when we ran Love 2D after installing? That is the default screen for when you do not have a game loaded in Love 2D. It will show you the balloon sort of wrapper screen. I will hop into GD50 just after completing CS50. You were superb, says Rito. Thank you so much. I appreciate that. It's very kind of you. I hope you enjoy it, and I hope you make lots of awesome stuff. Can you share your itch or somewhere where you have published something? I haven't actually published a lot of, the most I've actually done for game corpus wise is probably GD50. So check out GD50 where every lecture is a different game. Relatively like comprehensive in terms of showing sort of like at least at a primitive level what all the building blocks for a full game are. There's a lot of code there. There's like, I want to say 10,000 lines of code in aggregate maybe. But I'm not sure. It's been a while since I've done a code dump, line of code query on that code base. But there's a lot there, so check that out. Best OS for game development, Windows or Mac? Probably comparable these days, since Unity especially is available on Mac now these days. Mac, I mean, traditionally probably wasn't as used, but for a long time, Mac's been good. What's covered in CS50G? A lot of stuff. We cover Pong is the first lecture. Basically, we just got a sampler of the first Pong lecture. But we cover Pong and Breakout and Flappy Bird and Angry Birds, Super Mario Brothers, Zelda, Pokemon, Unity to a lesser extent with Portal and a couple of games based on like there's a horror game and a 2.5D sort of scroller. So yeah, we go into a lot of stuff in GD50. So check it out if you're interested in games. I feel like it's a decent intro, but provide feedback. Let me know. Do I participate in game competitions like Ludum Dare? I do not, but it looks cool. I've thought about it. What game inspired me to get into game dev? A lot of games. Probably, I played a lot of like JRPGs and stuff when I was young, like Final Fantasy and like Mario and Zelda and like all the classic Nintendo stuff. So most of that stuff, like PS2, like Jak and Daxter, like all that kind of stuff. Do you need the special gaming keyboard? You don't need it, but it certainly is nice to have. I have a gaming keyboard. Are you still putting out new music mixes? No, I haven't done music in a long time, although I thought about it. I kind of miss it a little bit. If I ever make a full game, I'll make some music for it. What should I learn in programming to make games other than if statements and loops? Functions. You're gonna want to learn classes, probably. Object-oriented programming is common in the world of games. Yeah, things like structs and C. If you're in C++, doing more low-level stuff, you want to get familiar with pointers. Data structures, obviously very important in the world of game development because games are effectively you manipulating data structures in real time really quickly. So data structures is important and algorithms. Although there's plenty of libraries that make it easier to not have to do all that from scratch. anymore. So you can focus just more on the juicier stuff, but your mileage may vary. Any lessons that I would like to share that could have been done differently while learning game dev? Maybe focus more on making things than trying to learn concepts, because the most I've ever learned has been from trying to make full projects and specific features that I was interested in, rather than Googling tutorials and stuff. Like try to make something that you try to make a game, or like a spoof of a game that you like from scratch as best as you can, and that will be I think way more helpful than trying to just follow along a tutorial, because you're using your brain more actively. You're not like copying stuff, you're actually producing. I think that mentally for me, that made a big difference. I would recommend that. Is Python good for game development? I'm sure it is. Yeah, I mean, there's like PyGL and Pygame and all sorts of other libraries and stuff that are used in Python. I don't do a lot of Python game stuff, but I've heard people talk favorably of it. So yeah, give it a try. Honestly, I don't think too much in terms of whether something is good or bad for X or Y in the world of programming these days so much, because it's only as good as you are willing to make it possible. There are limitations you'll run into at the very upper echelons of whatever you do, and then you'll have an informed idea of what may or may not be technically good for you to do something. But especially at a beginner to intermediate level, don't worry so much about that. Just like use a language you enjoy and a framework you enjoy, make stuff, and just kind of like sample other things. What do I think of pseudo 3D games on Love 2D? Last I looked at that being a thing, it seemed like it was pretty hard. It was pretty, like the API for it was pretty underdeveloped, although people were working on it. But if there was a 3D API that was comprehensive, like Love 2D's 2D API, I think it'd be pretty fun. But unfortunately, last I looked at it, which was admittedly a year or two ago, there wasn't a lot of headway in that space. It was just kind of like an object loader and a little bit of primitive camera stuff. But I know some people have expressed the desire to make that a thing. So it'd be cool if they expanded on it. Do games use databases to store large data like user info? Online games use databases to store stuff like that, but games that you run on your local machine are often just going to, they're just going to be stored in files that get loaded. And then they get written to when you save or auto saved. Any tips for getting into the game industry? Get good at programming games and making games and apply to companies. Make games yourself as an indie developer that you publish on platforms like itch.io or Steam or the like. Collaborate with other programmers and artists and stuff and make friends, network. I'm not huge into the game dev space. I'm actually full-time a web developer, but if I were to seek a job in the industry, that's probably what I would do right now. Is this course part of the professional degree? It's an extension school course in certain semesters, in which case it's part of a certificate through the Harvard Extension School. How do you export the game? There's a way to bundle your game with the Love executable. You have to Google how to bundle Love game as an exe or the like for Mac or Windows. There's a way to do it, but it's not something that off the top of my head I remember how to do. But there's definitely a way to do it. All right. Can you make a game with HTML? Yeah, HTML5 and JavaScript. So not with HTML by itself, but using JavaScript as a scripting layer, you absolutely can, using an engine like Phaser or many other different game engines in JavaScript. You absolutely could, 100%. You can make a game in just about any language as long as you find a framework for it. That's going to be the challenge. And obviously, the more popular languages have more support for that kind of stuff. But yeah, absolutely. So it looks like chat is wrapping up a little bit. So I want to thank everybody for tuning in. This was an awesome seminar. Lots of engagement on a bustling Saturday. So thanks so much for tuning in. If you liked what you saw, again, GD50 or CS50G is available online for free on edX. And also fill out the feedback form to let us know how we did. So this was CS50 or pre-CS50 games edition. Thanks again. I'll see all of you in the future. I look forward to checking out all the games that you send me. So ta-ta for now. Good luck in the future. Bye-bye.